confession. I love peanut butter and jam sandwiches. Have you ever wondered what I'm wondering? How come if you put peanut butter on one slice and jam on the other, you open it up, peanut butter and jam are stuck on both slices of bread? Why do they stick together like that? In fact, have you ever wondered what Maya is wondering?
Why is there sticky stuff?
Well, Maya, I don't actually know why there's sticky stuff, but by the end of the show, I'll find out. And wearing this special suit, I will throw myself at the wall, which is made of this special sticky stuff, and see if I stick to it, just like my phone.
Who invented sticky stuff?
I checked, and humans made glue 70,000 years ago. Just like us, prehistoric people needed glue to help one thing stick to another. Ancient humans discovered that by mixing tree sap with other stuff, they could make a strong glue. Speaking about making glue, here's a question from Noah. How do you make things stick? To answer that, he knows all about stuff that sticks. He can glue a duck to a stick. Here's chemical engineer Phil Scriver.
Hi, Zoe.
Wow, you really can glue a duck to a stick. Will you stick around to help me answer some questions about glue? I was talking to Phil. So, to answer Noam's question, how do you make stuff stick?
The first thing you really have to do is pick the right type of glue. There's a lot of different things in the world that stick, and that's because at a very small level, things aren't really flat. They actually have little branches off them, and those things stick to each other when they come in contact. Do you think that water is very sticky?
I don't think so.
It doesn't seem like it's very sticky, but when you think about getting out of a swimming pool, you have water stuck all over your arms. Let's try it with these discs. Let's put a few drops of water on there. So do we think that's gonna stick to each other?
No.
I'm just holding on to the very top one.
Whoa.
And it's stuck.
That's crazy.
So the water likes to stick to the two plastic discs, but it doesn't stick to itself very well, so it'll slide down. How about some jam?
Sure.
So in jam, you have a lot of sugars in there, and sugar has a lot of different branches on it, and those branches can cling onto things and make it very sticky.
Whoa.
It sticks that way. What about sideways? Do you think it's gonna drop right away?
No.
It's starting to drop a little bit, but it's much stronger than water. Now, can you pull it apart?
Let me see. Yeah.
So it does a good job of sticking to the plastic, but again, it's not sticking to itself very well. And that's really what makes a good glue, is not only does it stick to what you're putting together, but it needs to stick to itself.
Now for some real glue.
It takes about 10 minutes for it to fully dry.
Oh, that's really stuck together. Okay, this is nothing like what happened to the water. This glue sticks to the plastic and to itself. The water stuck to the plastic, but not to itself.
This is a giant Post-it note.
Wow.
So what we're gonna do is we're gonna put the adhesive of one Post-it note, which is here, and we're gonna stick another one to it to see how strong it is. We'll give you some gloves to make sure that you don't get any paper cuts.
Oh, wow, that is hard. Hey!
You see, the paper broke before the glue separated from itself. That shows you how strong it can be.
Phil says the sticky note is full of bubbles, so it's easy to peel off because the bubbles only touch a small area. Join two sticky notes together, and they're still easy to peel off. But if you pull on them, the bubbles get locked together, making the bond super strong. Try it at home. Ah, I ripped the paper again.
But again, if we peel it in the other direction, it comes off.
Wow. Thanks for being on my show and helping me find stuff out.
You're welcome.
I'm sure my viewers were glued to their televisions watching. It's amazing that there are so many types of sticky things. But what's even more amazing is that it wasn't actually people who invented the first sticky thing. Bees make honey, and you know how sticky that is. Frogs, salamanders, and chameleons all have long tongues covered in a layer of mucus. That's sort of like snot. Blech. And I found out that the mucus is sticky, but not sticky enough to actually hold the prey. See? So the tongue takes the shape of a suction pad just before it catches its prey. The sticky mucus helps create a seal so it can catch its prey. Ta-da! But there are other animals that make sticky stuff too. Here's a question from Eli.
How come a spider doesn't stick to its web?
I checked, and the answer is pretty amazing. Spiders make a glue-like material that's stretchy and sticky. So when a bug flies into the spider's web, it gets stuck and can't escape. But spiders can walk on it quickly because their hairy feet keep them from sticking. Spiders also build resting places without the glue, so they don't get stuck. Smart! But some animals do the opposite. They want to stick to things. I found out that lizards called geckos can stick to walls and even hang upside down because their toes are covered with millions of tiny hairs that use very small electrical forces to stick to almost anything. And now, here's another sticky question.
Why do magnets stick to fridges?
Well, Linnea, I checked, and here's what I found. Magnetism is an invisible force. It's not sticky like glue or honey, but it can make certain things stick to each other, like this. I'm trying out this magnet on different kinds of things. And as you can see, it only sticks to some of them. That's because magnets only stick to things made from the minerals iron, nickel, or cobalt. Let me show you with my super zoom-o-matic. Magnets create an invisible magnetic field around themselves that attracts those minerals. Just like this bucket, a refrigerator is made of metal. And some of the metal is iron. And this invisible magnetic energy field is attracted to iron. And that gives me an idea for... my Great Challenge!
Today's challengers are Bleach from Team Spider.
Hey. Team Spider!
And Coyote, your Team Gecko.
Woohoo! Team Gecko!
Both of you have the same number of mascots.
Some can be small and heavy, others big and light.
Your challenge is to stick your mascots to the wall panels using the magnets on your table. But here's the catch. Some of the small magnets can be stickier than the big ones, and some parts of the walls can respond to magnets more than others. Ready?
Yeah.
All right, go.
Team Spider picks a big magnet and a big spider, and it sticks.
Got it.
Team Gecko sticks a small gecko. Spider doesn't want to stick.
Oh man, it's so hard.
But neither does that gecko. Team Gecko trying a smaller but stronger magnet.
Some of these magnets don't work for the other ones.
That's right. Not every magnet is strong enough to hold up every creature. That one sticks. Good, Gecko.
Team Gecko has 2 right now.
Gecko trying a large magnet. Gets number 3. There's 4. Team Spider gets her second.
You're going down, Belize.
Go, Team Spider! Spider chooses a big magnet, looking for the sticky spot. Yes! Are Gecko's feet sticky? Yes. Team Spider with one that is just too heavy for the magnet she chose. She's trying a smaller but stronger magnet. Small magnet, large spider. That worked! Small magnet, small but heavy gecko. And Spider doesn't want to stick. But Gecko does.
Last one. Done.
Team Gecko, you win.
Woo!
So what was the trickiest part?
Some of the small magnets were really tricky because I thought they would be not as sticky, so I'd put them with the smaller ones, but then they would stick really hard and I wouldn't have any really sticky ones for the big ones and they would all fall.
The hardest part was finding which ones stick with which and where does it go.
Well, challengers, thanks for being on my show. Now here's a question from Noah.
Is it possible to make glue with ordinary stuff?
Uh-oh, do try this at home. My friends Christopher and Alyssa are gonna find out. They're trying a really simple experiment with just 2 ingredients, flour and water. Mix them together, and you've got glue, which you can use for paper mache. It's great for making stuff. But now, Sienna and Spencer are gonna make an even stronger glue. First, mix some vinegar and milk together. Filter the liquid out, and you're left with curds. Mix in some baking soda and a bit of water, and you get a pretty strong glue.
I think it's ready.
Bye, Zoe. Bye.
It works. Now, here's a sticky question from Anthony.
Is it true that they use glue to make big airplanes?
Glue to make airplanes? I don't know about that. I wonder what other kids think.
Glue is not the strongest thing that you could use to build an airplane. It would just crash, it would break.
It will fall onto the ground. It wouldn't have enough strength.
What if it starts raining? It's gonna get so wet, it's just gonna fall off and the plane's gonna fall apart.
It'll crash and fall, and
That would be a bad experience for a plane.
Guess what? I found out that they do use glue to make airplanes. And not just for toy planes like this one. Real jet airplanes, flying faster than the speed of sound. Thousands of meters in the air. How is that possible?
Head getting warm, brain swirling with synapses as strong as G-forces, starting to go unglued! You're gonna make my head explode!
How is it possible to use glue to make an airplane? To find out how it's possible, I came here to the National Research Council's Flight Research Lab. Hi, Lucy.
Hi, Zoe.
So, what do you do here?
I'm an engineer working on aerospace materials and structures.
Lucy tells me that materials used in airplanes have to be very strong and very light.
Why would anyone use glue to make a real airplane?
Take a look at this plane. What do you see here?
I see screws, and what are those bumps called?
Rivets. What do they do?
It looks like they're holding the parts of the plane together.
Yes, they add a lot of weight. And also at the same time, the rivets that are poking out from the surface add a lot of resistance for airplane to move forward.
Lucy tells me that because the rivets stick out, they drag through the air and slow the plane down.
So, what's this about glue? Why is it better?
Let me show you. Take a look at this airplane. This airplane is made out of composite materials.
So what are composite materials? Lucy says it's fibers held together with glue. Composite materials are really strong and much lighter than metals used in older airplanes. Glue is also used to hold composite parts together in newer planes.
Now, what do you see on the surface of the skin? Nothing. Do you see any rivets?
No.
So this airplane is made and held together with glue?
Yes, it's a much lighter structure, and without the rivets, there's less resistance for the airplane to take off and to fly faster.
Airplanes made with glue really won't fall apart?
Let's do some experiments to prove it, but we'll need some help.
Hi! Oh, it's Lucy's son, Alan.
And we're at National Research Council Canada. We make stuff and we break stuff.
It's pretty amazing.
Today, I have a set of experiments to prove glue is strong enough to hold an airplane together. Okay, let's put on safety glasses. Those are the stuff we're gonna use for our experiments today. They're real materials that real airplanes are made out of. And today, we're going to glue those pieces together the way we glue real airplanes together.
This kind of special glue is red, and it comes in sheets packed in white paper. We pull one piece of paper off and put the glue on the part.
Don't worry if it's not perfect, you can always move it a little bit.
Then we take off the other sheet of paper and put the other part on what we want to glue. Then everything goes on this tray. But it's not sticking yet.
Now we're going to cook it. What is this anyways?
This is called an autoclave. It is the biggest oven you've ever seen.
This oven is gonna make the glue really hard and strong. And this is the machine Lucy uses to test parts. It pulls on them until they break. That's how we can tell how strong something is. Oh, our part's ready to test. Let's try it out.
Isn't that cool?
Yeah.
Wow.
Okay, we've got the part in the high-tech destruction machine, and we're turning it on.
This one will be different.
Nothing's happening.
Yes. And get ready for action. Hear sound? That means something is possibly something is breaking. Wow! Whoa! Did you hear that?
Still nothing's happening.
To make sure airplanes are super safe. Whoa! Look at that.
Mama, something
Look
shooted.
at that.
Something shooted outside.
That's so cool.
Yeah. So you see where it broke?
Yeah.
It broke somewhere near the wing.
So the part broke, but the glue didn't?
That's correct. So the glue is strong enough to hold the airplane together.
It shows how strong glue can be.
All right, let's see how well glue really holds this plane together. Woohoo! So far, we've seen sticky things that we humans have made on purpose. But we make other sticky stuff, whether we want to or not, as this question from Alessandro points out.
Why is snot sticky? Ew.
Flat Earth Corner! Ugh, snot! Why it's not sticky? Well, here in ancient Greece, we're not actually sure why yet. But we doctors do know what snot does. It sends vapors to your brain that make you sluggish and lazy. Ah, my peanut butter sandwich. I feel a little bit tired. Ew. Maybe someone mixed snot in the peanut butter. It's so good though. Nowadays, scientists know that mucus does not create gases that make you tired and go into your brain. It's actually there to protect the sensitive insides of your body from stuff like germs and dust. That's why it's sticky. Things stick to the mucus and don't get in your body. And that gives me an idea for a song. Some people think that's not as icky. There's a reason that it's sticky. 'Cause germs and pollen, sand and dirt should not be up where they cause hurt. So if someone tells you snot is sticky, tell them it's supposed to be sticky. And they might like to think it's gross, but it's not. It's not! It's not! It's not! Boy, what a difference an S makes. Snot! Things that feel sticky aren't the only things that stick, though. Remember those magnets? And what about this sticky stuff?
Why does this stuff stick together?
To help me find out, Julie Berry is here from Velcro Companies, which makes the original hook and loop product that keeps our clothes and shoes on. Welcome.
Thanks, it's great to be here.
So, what are these products and how'd they get invented?
In the 1950s, there was a Swiss inventor named George de Mestral who happened to take his dog for a walk in the woods. And as he was walking his dog, these little burrs started to stick to the dog's fur. And so he pulled them out and noticed that they had these strange hooks on them, and it was the hooks that was grasping the dog's fur, and he had an idea to create a product. These straps are made up of two sides. So you have a very soft, fuzzy side. We call that the loop. And the side that sticks to the loop are hooks. And if you look at them very close under a microscope, you'll see thousands of tiny, tiny hooks that are able to grab the soft part of the product.
I think the time has come for me to try it out. Are you sure this will work?
Oh, absolutely.
Well, then don't try this at home.
Here we go.
This is incredible! Thanks for being on Finding Stuff Out and making the student wall for me.
Thanks for having me. I hope you had fun.
I had so much fun.
Awesome.
Bye.
Bye.
And that takes us back to the question that started this sticky odyssey.
Why is there sticky stuff?
Well, Maya, the big answer is... In order to survive, certain living things use stuff to stick to other stuff.
Some animals need sticky stuff so they can catch their prey. Plants have sticky pollen so that insects can carry it and help them reproduce. Our body makes sticky stuff to stop germs and dust from getting inside. And we've invented sticky stuff to do all kinds of jobs. Yeehaw!
Wow, this is really sticky. Julie, still there? Mom, Dad, can somebody get me off this wall?
Well, there's no point of you sticking around. See you next time for more Finding Stuff Out. Man, I wish I had a peanut butter sandwich. I'm having a party later today. My friend Erica and I share the same birthday, so we're having a double birthday party. But first, I'm going to Erica's house to bake the most awesome cake ever. And maybe even do more because of this question from Maya.
What type of experiments can you do in your kitchen?
Well, Maya, I definitely think baking is an experiment, especially if you're making something for your first time. This was supposed to be a fluffy cake, but I ended up with this mess. But I'll get the answer to your question by the end of the show. And plus, Erica is a winner of a TV cooking show, so our experiment is going to be awesome. Hi, Erica.
Hi, Zoe.
Look what I brought.
Cool. Thanks.
Hey, Erica, do you think cooking is like an experiment?
Cooking is exactly like an experiment. You follow a recipe and see regular ingredients transform into something totally different. So first, we're gonna start with the sugar, so you can add this to the flour.
Okay. Our tasty experiment uses dry ingredients like baking soda and baking powder.
Wow.
Then the wet stuff. Good?
Yeah.
Put it all together and mix it up.
So now we have to add the thing that makes this normal vanilla cake a funfetti cake. So the sprinkles.
It looks so fun. This is gonna be one tasty cake. Once it turns into a cake, that is. Which reminds me of a question I got from Adriana.
What makes a cake rise?
It says magic on the box, but it's not really magic powder, right?
No, it's not magic, it's science. It works with the baking soda to create little bubbles of gas.
Cool.
Both baking powder and baking soda create a cool chemical reaction. It's kind of like when you mix baking soda and vinegar. Watch that chemistry in action.
It creates little bubbles of gas. That's what makes our cake rise. Once we add the baking soda to the cake mix, we have to put it in the oven right away.
That reminds me of an experiment my friends did. It uses baking soda too.
The experiment!
Hi, Raphael and Amber.
Hi, Zoe.
So, what are you cooking up in your experiment?
It's a secret. We mix baking soda and water in a bowl.
Now we could draw something on the paper.
Are you guys sure about this experiment? I don't see anything.
You're not supposed to.
Not yet.
Oh, I see. It's like invisible ink.
Yes, we just have to let it dry. Now we paint lemon juice over our paper.
The lemon is acidic and it reacts to the baking soda.
And it makes our invisible ink appear.
Oh, yeah. This is pretty cool. I see it now.
Happy birthday, Zoe!
That chemical reaction was kind of like the way baking soda reacts with the acidity in our cake mix. It was important to add the right amount of baking soda and baking powder to our cake, or else it wouldn't rise properly.
When my family and I cook, if we make a mistake, we can usually turn it into something anyways and make it work. Like one time, we turned spaghetti sauce failure into tomato soup.
Cooking is like an art, but baking, it's super precise, like a science.
Hang on. I feel an experiment. Yes, a musical experiment.
I'm a cook. I'm a baker. Secret spices in my shaker. I can bake an awesome caker. A pinch of pepper, a dash of salt. I must measure without a fault. Forgot the meat, no need to worry. No baking soda, I'm going blurry. Instead, I made a Zoe surprise. Ha! But my souffle, it just won't rise. They say that cooking is an art. Baking's like science, just look at my chart. I use any ingredients I have on hand. Hey, I can do this cool handstand. But together we can make a delicious meal. Okay, my friend, you got a deal. You got a deal. You got a deal. You got a deal.
Well, thanks, Erica. I can't wait to taste the cake later. I'm making dough for my mini party pizzas. I hope this experiment works too. Check this out. I let this dough sit for a few hours, and now it's double the size of this one. It's because I put yeast in the dough. And yeast makes things like pizza dough and bread rise. But I'm kind of wondering the same thing as Max.
If yeast expands in bread, can it expand in your body?
Me big, me full of yeast.
That's scary, but I know someone who can answer the question. He's got all the info on how yeast makes things grow. Please welcome my very special guest, Shakib Rahman.
Hi, Zoe.
Shakib.
I ate bread with way too much yeast in it.
Wait, what?
Kidding!
So, Shakib, what exactly is yeast?
It's a living thing, like a plant or an animal. Yeast is a kind of fungus that eats sugar and starch. When it's activated by heat, the yeast eats the sugar and basically farts out carbon dioxide gas. That's what creates the little pockets of air in the dough that make it expand. But the yeast eventually dies from the heat of baking. Also, the acid in our stomach is so strong that it ends up killing the yeast before it can fart out any carbon dioxide. That's why if you eat any bread, you don't get all gassy afterwards.
Phew. But what's the difference between yeast and baking soda we use in our cakes?
Baking soda produces a chemical reaction. It's very, very fast.
Oh, so that's why Erica said to put the cake batter in the oven right away after we added the baking soda.
Yeah, that's right. You had to get those air bubbles trapped in the cake before they escaped. Yeast, unlike baking soda, is a living thing. It produces its carbon dioxide very, very slowly.
So that's why my pizza dough didn't rise so fast.
Exactly. Do you want to try another experiment where we can make some chemicals rise?
Yeah.
I've got exploding elephant toothpaste here.
Cool.
We're using chemicals, and this experiment is going to create a lot of heat.
Safety goggles, safety gloves, check.
The first thing I'm gonna do is add some hydrogen peroxide in. So you have to be very careful with this stuff, which is why we have our safety gear on. Excellent. Do you want to add the dish soap for me, Zoe?
1, 2, 3.
I'm gonna add blue food coloring here. Now you've got to add the last ingredient, Special Chemical X, potassium iodide.
Whoa!
Can you see all the steam coming out of there, Zoe?
Yeah, I do.
Our hydrogen peroxide turned into water, which turned into steam because of all of the heat we're generating, and it also turned into oxygen. And our oxygen got trapped by all of the dish soap, which is why we have all of this nice foamy mess here.
That's so cool. It really does look like a giant tube of toothpaste that an elephant would use.
That's right, but don't try this at home without an adult's help.
That reminds me of another question I got from Leah.
What's an easy experiment I can make in my kitchen to make things puff up?
Well, Leah, some of my friends did a little bit of experimenting.
The experiment!
Hi, Adriana. Hi, Jonah.
Hi.
Are you going to amaze me with a Puffy experiment?
Yeah, we will.
We have our bottle ready for the experiment. I'm gonna put the funnel in.
And then I'm gonna put some baking soda inside of the bottle.
Just gotta make sure it all goes down.
Next, I'm gonna put some vinegar in the bottle.
I gotta be ready with the glove because I gotta get it on super quick. Check that out. It's like a ghost hand.
A ghost hand? Cool! The chemical reaction between the baking soda and the vinegar created bubbles of carbon dioxide gas that are blowing up the glove. Let's compare with the next experiment. This one uses yeast with sugar and water.
Let's begin. Put the funnel in. Now we do the water. Next, I'm going to add the sugar. Now I'm going to add the yeast. And now, shake it. Now let's get the balloon on.
Nothing's puffing up yet. This experiment with yeast is much slower.
Now we wait.
Wow, it's just like when yeast farts out gas and makes bread puff up.
The yeast is eating up all the sugar, and it keeps farting out gas.
It took 10 minutes to puff up, but it was worth the wait. Thanks for the cool experiments.
Bye, Zoe.
If I waited for yeast to blow up all my party balloons, I would have to wait a while. I'm gonna turn this place into Party Central. Hey, speaking of transforming something, Liat had another question about experiments you can do in your kitchen.
Could you turn food into something completely different?
Great question, Liat. Shakib has a magic experiment up his sleeve. Go ahead, Shakib.
That's right, Zoe. What I'm gonna do is I'm gonna take some potatoes and turn them into a really cool experiment. The first thing I had to do was I had to take my potatoes, cut them up, and then boil them in water, and then get rid of the water, so I ended up with my potato starch. Now, if you don't have an adult to help you, you can just go to the store and get potato starch from there. The next thing we have to do is take this potato starch, combine it with some tonic water. Mixing a little bit of this tonic water with the potato starch will give us the start of our cool experiment. Now, because this is a little bit messy, I'm gonna put on some gloves and mix this all together. It does this weird thing. It starts to form a solid. But that solid, when I let go of it, starts to flow like a liquid. This is something we call a non-Newtonian fluid. If I squeeze it hard again, you can see that it forms a solid, but by letting go of the pressure, we get a nice liquid that starts to flow again. Here's the magic part. If I turn off the light, something really cool happens. Using a black light, which gives off ultraviolet light, you can see that our potato goo now glows in the dark. The reason for that is the tonic water that we added earlier has a special chemical in it. It's called quinine. Quinine is something that glows when you put it in ultraviolet light. And that's our magic mud experiment.
Wow, that magic mud can't decide if it wants to be solid or liquid. It's crazy it could be both. And that gives me an idea for... My Great Challenge! On Team Solid, we have Daniel and Lex.
Whoa!
And on Team Liquid, we have Veronica and Fabiola. In today's challenge, you're actually gonna be both liquid and solid. Well, the magic mud you're going to be using is both. In each pot, I filled it with a bunch of items that have to do with cake. The team with the most items at the end of the challenge wins. Go! It's a pretty sticky challenge. Team Liquid has 2. Team Solid has 1 right now. Team Liquid is in the lead at 3. Team Solid has 2. Oh, Team Solid's catching up.
I got 1.
Team Liquid has 5. Team Solid has 4. 5. Team Liquid has 6. Oh! Team Solid has to keep digging if they want to catch up. They're trying to go fast, but it doesn't work because that magic mud gets really hard. Solid has 8. Team Solid's in the lead right now, guys. And they're at 9. Go, go, go. Oh, Team Liquid back on top. That was fast. There we go. Okay, time's up. You guys have 12, and Team Solid, you guys have 11. So that means we have a winner. Team Liquid, you win. Good job, guys.
Good job, guys.
Thanks.
So what was the stickiest part?
The magic mud. Because you think you have an object, but you really don't.
The stickiest part is that I can't get my hands out.
Well, thanks, guys, for being on my show.
You're welcome.
You're welcome. Do I bring this box with me? It's stuck
If you have to.
It's stuck to me like cement.
That was awesome. And it made me dream about birthday cake and a big glass of
Whoo-wee! This milk went bad. Ugh. It's like it's an experiment on its own. Ugh. That reminds me of a question I got from Anastasia. Why does the milk get disgusting and chunky when you leave it on the counter for a long time? She'll tell us why it gets lumpy, because bad milk sure makes us grumpy. Please welcome bacteria investigator Maya Hay.
Hey, Zoe.
Hi, Maya.
I brought you some food.
Food.
Yum. Do you see how the food is starting to change color and that there's some slime and fuzz developing on top?
Yeah.
That's because the food is starting to break down from bacteria. And the same thing happens with the milk. When milk breaks down, it gets clumpy like this.
That's gross.
Bacteria is in all foods. It's everywhere, actually, so this is totally normal. The bacteria take the natural sugars that are in milk and they make waste. But that bacteria poop is really acidic, and that reacts with the milk. When the milk starts to break down, it starts to get clumpy, and it curdles, just like that. Now, check this out. I have some of this bacteria that I grew on a Petri plate. Do you see any on this?
No.
That's because I only put it on this morning, so they haven't had a chance to grow yet. But check this out. Do you see any there?
Yeah.
So, how many do you think are in that Petri plate?
500?
Keep going.
10,000?
Keep going.
1,000,000?
There are billions in this tiny Petri plate.
Billions? That's like the entire population of the world! Imagine that in a glass of milk!
You're gonna make my head explode!
Slow your roll, bacteria. I found out there's a way to do that.
Bacteria move a lot more slowly in a cold place, so they don't multiply into billions as fast. That's why keeping milk and food in the fridge makes it last longer.
There's another way to preserve milk, and that's to use the help of bacteria. Here's what we're gonna do. This is some milk. And then what I want you to do is add this starter culture. It's basically a special mix of bacteria. I want you to add 2 tablespoons to it.
So these are good bacteria, not the kind that can make you sick?
Exactly.
2.
Great, now give it a mix.
What happens when we mix it?
So what mixing it does is it introduces the bacteria to all of those sugars, and then when you wait 12 to 18 hours later, it's gonna turn into yogurt like this.
That's crazy. So how does it do that?
It's called fermentation. Basically, the bacteria took the milk sugars and made it into an acid, and that acid reacted with the milk, and it thickened it just like this. Do you wanna try?
Yeah. Thanks. Now that's delicious. Thanks, Maya.
You're welcome.
It's pretty amazing there's good bacteria that we can use to make food, and then there's bad bacteria that can make us sick. There was a time when people weren't so sure what caused sickness.
Flat Earth Corner!
The evil wind is blowing. I must not breathe in the vapor. It will strike me down with the deadly cholera, poisonous wind, and disgusting smell. Why must you curse us with your evil stink? I cannot catch the disease. I must not breathe in the wind. Catching a deadly disease from the wind? About 200 years ago, that's what people thought.
In 19th century England, there was a huge outbreak of a deadly disease called cholera. A whole lot of people died from it because it couldn't be controlled. Back then, they thought it was caused by mysterious clouds of air filled with bits of rotting things and smelling gases. But a doctor named John Snow found something out. He discovered that city drinking water from some of the pumps were dirty and infected. They didn't have good sewers like we have today. So it wasn't because of something they were breathing. It was because of something they were drinking.
I'm glad we know so much about bacteria today. I'm also glad I didn't drink that spoiled milk before.
Oh yeah,
party time is getting closer. My friends and I love chicken wings, so these will be a big hit. Oh, that reminds me. Uh-oh, do try this at home. I put this chicken bone in some vinegar about a week ago. Check this out. You have to rinse it off and watch. A rubber chicken bone! The vinegar dissolves a mineral called calcium, which is what makes bones hard. Without the calcium, what's left is just this soft bone. Hi, guys! Hi! Wow, our cake looks delicious. It was definitely a successful experiment. I think I'm ready to answer the question that started off the show.
What type of experiments can you do in your kitchen?
Well, Maya, big answer is, drum roll please, there is no limit. Today we did experiments that used all different kinds of science, like chemistry, physics, and biology. Using kitchen ingredients, some of them were even good to eat. You can do tons of kitchen experiments with really basic stuff. The kitchen is our lab and we're the scientists. But here's my favorite kitchen experiment. Let's find out if the cake is delicious. Yeah! This is good. I love experiments.
I've been practicing karate because I had the same question as Joey.
How can you break things with a karate chop?
The short answer is not the way I did. There I was, getting ready for the big break. I'm lucky I didn't break my hand. And now I'm ready to try again. But I want to do things right this time. Maybe your questions will help me figure out how. And I promise by the end of the episode, you will see boards broken. Next question.
How do people break things?
How can you break things, Lily? Fall on them, bump them, crack them, hit them, step on them, pull them apart, crunch them with your teeth, throw them on the ground. So many ways. Uh-oh. Ah! You're gonna make my head explode. Making my head explode is another way to break things. Crash it, smash it, slash it, hash it. So many ways to make things break. Bash it, thrash it, gash it, dash it. Karate chops, big drops, or earthquakes. So many ways to make things break. Crush it, smush it. Easy does it! The surest way to break something in two is when you're trying very hard not to. Sorry. One of the most dramatic ways to break things is explosives. Check this out.
How do you break a rock?
Well, Sarah, to find out how we break rocks, I've come to a rock quarry. Here they take huge pieces of rock like this and break them up into gravel like this, which is used to build roads. And to show us around, here's Tony.
Harrison, nice to meet you.
Nice to meet you.
What we're going to do to break rocks is use explosives. Would you like to help?
Yeah, of course. Let's go.
do it, buddy. This is the area that we're going to blast. We've got to drill approximately 80 holes.
They put the explosives deep in the ground because they break more rocks that way. If they were on top of the ground, most of their power would just go into the air.
Harrison, this is our rock drill. It's a D9 that we use to drill a 4-inch hole to set up explosives in. So I'd like you to get in and drill some holes.
So I'm going to help you drill a hole?
You're going to drill the hole.
Oh, sweet.
And she's running. Whoa! You're drilling a 4-inch hole 40 feet deep, so we can put the explosives in the ground a little later.
Right.
What we have here is a stick of 1.5 inches by 16 inches stick of nitroglycerin-based dynamite.
Dynamite?
Dynamite! In my hand here is what we call the detonator, the blasting cap.
The blasting cap goes inside the dynamite. It's kind of like a firecracker. We'll make a small explosion in the blasting cap that will set off a huge explosion in the dynamite. Are you sure it's safe that I'm holding this right now?
Well, it's very safe.
Okay.
When we put this cap in, there's a hole in the bottom. Stick it in.
Just like that?
Yes, sir. So what we're gonna get you to do is hold that like that.
So I can drop it in the hole?
Drop it in. All right, now we've got that. I'm gonna ask Dustin, who's the blaster in charge here.
Nice to meet you, Harrison. Nice to meet you.
And he's gonna help us load this hole.
Seems like dynamite's not enough. We're gonna add this explosive powder on top of that to make a really big boom. So this is an explosive material?
Yes, it is.
Whoa.
Each one of these bags is about 25 kilograms.
Now we're gonna put the material around. And this is called stemming.
So you just throw rocks in there?
Just keeps the power in the rock so that it breaks the rock.
Right.
So let's do the same thing over again over here.
After we get all 80 sticks of dynamite ready, it's time to blow up some rocks. Let's go set off some explosives.
All right, let's do it.
We use these wires to connect the 80 dynamite sticks to a battery. And last but not least, we've got to get to a safe spot.
We've moved back far enough from the explosion.
So now we gotta hook it up the wires to this thing?
You hold that. I'm gonna put the wires on for you right now.
Okay.
We'll give it a little wrap. Okay.
I'm honking the horn 12 times to warn everyone that a blast is coming. Watch out, everybody!
Scream it.
Blasting!
Fire.
Oh my gosh.
Woo, good one.
What?
Awesome. Oh, you just
Tons
set
of TNT.
10,000 pounds of explosive off, buddy.
Wow, that's crazy. Our explosion turned this into this. Hey, let's see that again. Wow, is that ever cool? When I slow it down, you can see the blasting caps going off, setting off the dynamite and releasing the hot gases that blow the rocks apart. Whoa, look, it's just a big pile of rocks now.
That is awesome.
But they're still too big to build roads with. What do we do now?
Crush them. This is the jaw crusher on the end that the wheel loader puts in and then puts it into the crusher. There's that big one coming in, and that rock will break into a 6-inch mine. Wow, that's exciting, you know. That even for me, I still get excited over it. So that there,
yeah,
that's our end product coming out of there.
Nice. This is used for like roads and stuff.
It is, road and construction.
Wow, well, I had a blast. Thanks so much for being on my show, Tony.
Oh, it's a pleasure.
Why do different things break differently?
To help break down the answer, please welcome materials engineer, LV Dalgard.
Hey, Harrison.
Hey, so what does a materials engineer do?
Basically, I'm an expert on how stuff breaks.
Whoa, you get paid to break stuff? Cool. So Miles was wondering why different things break differently.
There's two main ways that things break. Ductile breaking, which is kind of stretching apart until it just pulls apart.
Like crazy putty.
Or there's brittle breaking, which is where things just snap apart, like this chocolate.
Or like the cracker, right?
Like the cracker, exactly. These balls are kind of somewhere in between, right? They're stretchy, but you couldn't really break them.
You can't crack them, can you?
Let's try. First, put your safety glasses on.
All right.
And we're gonna use this liquid nitrogen, which is really, really cold, 200 below zero.
200 below zero? That's more than freezing cold.
So we're gonna drop one of these balls in there.
Oh my
I'm gonna
gosh.
try to get it really nice and cold. All right, let's see if it's cold enough.
Normally, a hammer would just bounce off a rubber ball like this.
Ready?
Yeah.
Let's give this a try, right? 1, 2, 3.
Because it was frozen solid, the ball just cracked in half, like a cracker.
Well, Harrison, is there anything else you'd like to dip in liquid nitrogen and break today?
Would that work on one of these soft gummy candies?
Yeah, that's pretty stretchy, isn't it?
Look at this, look how far I can stretch it.
Let's see if it's gonna break.
It shattered like glass.
It shattered like glass.
I think I have another question. This one's from Cameron.
Why doesn't metal break easily?
Well, Cameron, I'll take that as a challenge. I'm gonna break a piece of metal with my bare hand. Hi, yes! Nice.
Well, that was just a piece of aluminum foil. But how come some metals are so hard to break?
Well, the aluminum foil was easy because there's not very much metal to go through, and aluminum is not one of the hardest metals there is out there. Can you break this?
Okay, like this metal desk right in front of us?
Yeah, try that.
Let's try this.
Sorry.
Not really. But how come?
This one's thicker, and it's also just a harder metal.
So sometimes you might think something made out of metal is strong, but it's not. Giuliano had a question about that.
Why did the Titanic sink if they said it was unsinkable?
The Flat Earth Corner! Ahoy! This ship is unsinkable. It uses all the most advanced technology.
I seem to have misplaced my binoculars. The captain asked me to watch out for icebergs. Oh well. This ship is unsinkable. Even if it did hit an iceberg, it would not sink. Whoa! People thought the Titanic was built to be unsinkable. No one would have ever thought it would fall apart the first time it sailed. But when the ship hit an iceberg, it ripped open. Here's why. The ship was held together with rivets, short metal pins that connect the big pieces of steel. The Titanic's rivets were supposed to be made of super strong steel, but the shipbuilders ran out of it. So they used a kind of metal that unfortunately breaks when it gets cold. Remember how Elvie showed us that could happen? When the Titanic hit the iceberg, the rivets broke and water got into the ship. Luckily, today we have safety rules on how to build ships so that they don't fall apart like the Titanic. Now here's a question from Serena.
Why when you throw a plate on the floor, there's big pieces and there's little pieces?
Let's find out.
Wow.
Wow. Well, it certainly did break into different sizes of pieces.
I love breaking things, but how come some of the pieces are bigger than the others?
Well, that's the question. Plates are made out of clay, which is actually made out of lots of little particles. You can kind of see them there. And in between all those little particles are little cracks and little holes. It's actually kind of like these paper towels. See how there's a line of holes right along it?
Right.
If you were to break this, it would break along those holes. You really like to break stuff, don't you?
It's for science. Oh, can you stick around? We're gonna do some more breaking, experimenting later.
Sure.
Awesome. Here's a question from Katrina.
Why do baseballs break windows?
I checked the answer, and the reason baseballs break windows is not just because you have bad aim when you throw. There's science involved. Let me show you on my super zoom-o-matic. Glass and everything else in our world is made up of tiny things called atoms, which can join to form molecules. Some molecules hold together very strongly, but some don't. To find out how it works, let's get some... Sheet sparks! Do you guys want to be molecules? It's for science. Yeah! Okay, so link together like your molecules that are really tight together. All right, now pretend that I'm a baseball and I'm gonna try to break through you. So hard, so difficult. Okay, I can't do it. Okay, let's pretend your molecules that are really loose together. Okay, now I'm gonna be the baseball again. I'm gonna try to break through you this time. Oh, yes, that was really easy. That's just like one way that a baseball can break through glass. What I wanna know is, have you ever broken anything? What is the worst thing that you have broke?
A lamp. A wall by slamming the door. All I did was open the door, then boom.
And the wall just like broke?
Yes.
My sister's video game by breaking it in half.
Was she very happy?
No, she was really mad.
A flower pot. I was running and I hit it and it fell and broke.
My aunt's flower pot. I was taking something out of the microwave, then I banged myself into the plant, then I fell on the ground.
A picture frame by playing soccer in the house.
Why were you playing soccer in the house?
I don't know.
Were your parents mad?
Yeah.
If you want to learn how not to break things, it's time for My Great Challenge! My Great Today, my challengers are Dahlia, Yusuf,
Hi.
Olivia,
Hey.
Erica,
Hi.
and Mateo.
Hi.
Today, your challenge is to try not to break an egg. Do you think you can do that?
Yeah.
All right, everybody take an egg. Now watch this. To prevent your little buddy from ending up like that, use the stuff in the bins. There are sponges, marshmallows, papers, string, all kinds of useful stuff. Do whatever you want to it to try to make it not break when it's dropped from all the way up there.
Oh my gosh!
You'll have 3 minutes to wrap up your egg. First of all, though, we're gonna get you to draw faces on your eggs, yes, with these markers, so that we all know whose egg is whose.
Mine is Humpty Dumpty. Here's Eggy. Here's Scrambled. Here's Shelly.
Here's Commander Cody.
All right, you guys will have 3 minutes to protect your egg. Are you ready?
Yeah.
Get set, go!
Is there bubble wrap? Okay. Never mind.
Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, time's up. Okay, are you guys ready to see whose egg survives and whose turns into an omelet?
Yes.
All right, first one. Are you ready?
Yeah.
3, 2, 1.
Whoa. I think that one's mine.
Here's the second one.
It looks like an egg falling out of
It bounced that one. Okay, ready?
Mine came out.
Here we go. Ooh,
Oh god, yours
that sounded,
It bounced.
Mine bounced.
that sounded like a crack.
Omelet.
It bounced.
All right, so go grab your eggs, and then I'll help you open them up and inspect them. Oh, I've got yolk.
I know. It's epic
So it's-
omelet.
Oh, it's definitely an omelet. There's yolk coming out of it. Bounced, eh? Okay, let's open this guy up. See how Humpty Dumpty's doing.
Humpty
Let's
Dumpty.
see, where is he? Yeah!
Humpty survived.
He's safe.
Oh, Humpty.
Okay.
Scrambled, are you safe?
Scrambled is
Yes,
safe.
looks safe to me.
Scrambled safe.
Let's see. What is it, Commander Cody?
Yeah.
Oh, there's a lot of sponges around the thing. That's probably why he bounced, eh?
Act like I told you.
He's safe. Commander Cody survived. Last but not least. There, Shelly. Shelly looks safe.
And I would tape.
Let's check. We gotta make sure.
Of
Yep,
course he's
Shelly's safe.
Shelly's safe.
So 4 out of 5 eggs are safe. Well, please welcome back Elvie. She's gonna explain why this happened.
So if you were gonna fall on the ground, would you rather land on a giant marshmallow or just on the ground?
Marshmallow.
Yeah, eggs too. If you squish a marshmallow, see how you can't really squish it fast. It kind of slows you down. And that's what happens with the egg too when the egg lands. So it spreads out the impact and it also cushions it so it doesn't land so fast. It slows it down. And that's what happened with your eggs. Good job.
Okay, so today we broke an egg, a plate, a rubber ball, and I've blown up rocks. But I still haven't figured out how to answer Joey's question.
How can you break things with a karate chop?
I'm gonna need a karate expert. Please welcome Henry Chibozo. Whoa. Sensei! You're really good at karate. How long have you been doing this for?
Oh, long. I got my black belt when I was 16.
Wow. Well, I've been doing a lot of breaking things around here today, but I think I'm gonna break a brick now with my hand.
I don't think it's a good idea.
Just watch me.
Harrison, it's not a real brick. It's styrofoam.
You got me. Well, when I was trying to break a board with my hand, I almost broke a bone.
First of all, you have to do it with someone who knows how to break a board. You have to have a strong mind, and you have to have a lot of practice.
Right, well, can you show me?
I show you how I break a boards. Boards, please.
Can you do more? Whoa.
3 boards, please.
3 boards? 3 boards. Can you break a board with your foot now?
Of course. Can I have a board?
That was awesome. Okay, I guess it's time to answer Joey's question.
How can you break things with a karate chop?
The big answer is, yeah! You need a bunch of things working together just right. We saw today that even hard things can have weak spots. The pine wood that Henry broke has seams, sort of like the paper towels Elvie showed me. Those are its weak spots. Our hand bones are stronger, and the flesh around them cushions the blow. Sort of like the way marshmallows and sponges protected our challengers' eggs. So, when a karate master hits the wood's weak spot with just the right speed and power, the wood breaks. But it takes a lot of training. Can you show me how to do that?
I'll show you a beginner's technique.
Oh, this can be today's. Uh-oh. Do try this at home. Breaking a board is for very advanced karate students. So today, we're gonna show you something that you can start training with.
We're gonna try today to do a kick. Go in position, like that, the left leg forward. Your knee go up, and you do a kick. I'm gonna show you first.
Okay.
Okay?
So, there and then.
Exactly. Okay. 1, 2, 3.
All right, I think I'm ready.
Good.
I can break a plank, right?
Yeah. Bring the special plank loose.
Oh, a baguette. Okay. Hi-ya! I did it!
Nice.
Thanks for helping me find stuff out. Stale baguette. That's like the hardest thing in the world. Whoa, this lump of coal is hard. You're probably wondering why I'm trying to squish it anyway. Well, it's because of a question I got from Benjamin.
When you squish a piece of coal, how does it turn into a diamond?
How does a piece of coal turn into a diamond when you squish it? I don't know. I don't even know if it's possible. But coal is carbon, and diamonds are carbon. So, I'm gonna find out the answer because if I can turn this coal into a big sack of diamonds, yes, I'm rich. I'm rockin' rich. Diamonds are one of the most valuable rocks in the world. Kings used to put them in their crowns, and today they're used in fancy jewelry. The most famous diamond in the world is called the Hope Diamond. It's supposed to have a curse. Diamonds are hard to find though, so if I want to have some, I'll have to make them. I guess I have to do more research. Meanwhile, here's a question from Madison.
What's the difference between rocks and minerals?
I checked, and rocks are made out of minerals, but minerals aren't made of rocks. Wait, what? How can rocks be made of minerals, but minerals aren't made of rocks? Do scientists have rocks in their head? Brain getting warm, brain starting to go volcanic. You're gonna make my head explode! It might sound confusing, but I checked and it works sort of like this. Minerals are like the parts of a sandwich. The bread is just bread, lettuce is just lettuce, the cheese is just cheese, and the tomatoes are just tomatoes. But if you put them all together, then you make a sandwich. And this one's got my name on it. That's good too. Rocks are like the whole sandwich. Put some minerals together, and it's a rock. Also, don't talk with your mouth full, especially if you're doing a television show. Now here's a question from Leo.
How does a rock become a rock?
How does a rock become a rock? Let's answer it with some hard rock. Rock cycle, time to get down. Rock cycle down in the ground. When the pressure pressure starts, then things get hot. You're gonna get molten rock, smushed up minerals all combined to make the different rocks we find. Mountains are born, then they get worn down. New rock, old rock, switches around in the rock cycle. Yeah, rock on, rock it out. Now here's a question from Munir.
How many kinds of rocks exist in the world?
I don't know, Munir, but I know someone who does, and he rocks. Please welcome Matt Herod. Oh, hey, cool rocks.
Oh, thanks, Harrison. They rock.
Rocks! So how did you get started into collecting rocks?
So I started when I was 10. I was given a little kit of different minerals as a Christmas present, and that got me really interested in learning all about rocks, reading all about them.
Okay, so to answer Munir's question, how many rocks are there in the world?
So there are 3 types of rocks on Earth. There's igneous, metamorphic, and sedimentary rocks. Igneous rocks form when we melt other rocks, like in a volcano or something. This rock has quartz, feldspar, and mica.
Wow, so that could have come out of a volcano?
That's right. When this rock cooled, those 3 minerals formed. This is a sedimentary rock, and you can see it's just like a big bunch of mud all hardened together. Sedimentary rocks form when we break apart other rocks, and the sand or the mud that forms washes down a river, and eventually it settles down, and then eventually it hardens to form a sedimentary rock. The final type of rock is metamorphic rocks, and they're formed when we take an igneous rock or a sedimentary rock and we bury it really, really deep in the earth.
I found out that it's super hot in the middle of the earth. So these kinds of rocks melt down there and get squished together, right?
Exactly. All that heat and all that pressure causes it to change into a metamorphic rock.
So that's 3 ways that rocks can get made. But how many kinds of rocks are there altogether?
Well, when we change the way that they form, different conditions, we can get all sorts of different combinations and make thousands of different types of rocks.
This is your collection of rocks here. Is this your full collection?
No, I have so many more rocks back home. I haven't filled up my attic, but I certainly filled up the basement and the garage.
Well, Tatiana had a question about some rocks that are out of this world.
Are rocks different on other planets than Earth?
That's a great question. Some rocks on other planets are a lot like the ones we find on Earth. Others are completely different. So today I brought with me a sample of a meteorite.
You mean a rock that fell to Earth from outer space?
Exactly.
Why are you putting that glove on?
Because the grease on our fingers can actually contaminate the outer surface of that meteorite or ruin it if scientists want to analyze it. So here's the meteorite I brought. And you can see on the outside, it's all burned and brown.
Yeah.
Like I just took it out of my oven. But that's actually from when it flies through the earth, it starts to heat up, and then it gets this outer brown color on it. That's called the crust. So this meteorite's been cut in half, and we can see that the inside is all speckled with different types of minerals inside.
Munir, Matt says that the rocks astronauts brought back from the moon and the ones that were studied on Mars show us that rocks from space can be different from ours on Earth. But scientists think that the minerals they're made out of are the same everywhere in the universe.
In fact, we believe that there might even be a planet that's made of diamonds.
A planet made of diamonds? If you found that planet, you'd be so rich.
Yeah, it's really, really far away, though.
That reminds me of a question from Malinka.
Why are some rocks worth more than others?
Yeah, so why are some rocks worth more than others?
So the first reason is rarity. If it's really hard to find, and if there's not very much of it, then it's going to be worth more. The second is if it's really useful. If it's a mineral that can be used for something to help people, then it's going to be worth more.
Oh, I heard iron ore helps make steel, which is used to build things like bridges and cars. Is that why it's worth more?
Exactly. And the third reason is it costs more to get out of the earth, then it's going to be more valuable.
That's why diamonds are so expensive, right?
That's right. Diamonds are really hard to get out. They're really rare, and they're both pretty and desirable and useful.
Cool. Can you stick around to help me find more stuff out?
Yeah, my pleasure.
Awesome. Now here's another question. This one's from Gianni.
What do you use rocks for?
So Gianni asked me what rocks and minerals, like metal, are used for. I thought of some answers, but I was hoping these guys could help me figure out some other things that are made out of rocks.
Pyramids, railings, earrings, fences, houses, garbage cans.
Golden medals, like for the Olympics.
The kettle that you make tea or coffee in. Cars and some lamps. Watches and lampposts. Cement. Pots, pans, statues, wedding rings, TVs. Almost everything are made out of rocks.
Wow, you sure use a lot of rocks. So Gianni, to answer your question, looks like we couldn't get by a single day without using rocks.
That's a lot of rocks!
Here's a question from Victoria.
I like to have some gold. Where can I find some?
The Flat Earth Corner! In medieval Europe, scientists called alchemists thought they could actually turn common metals like lead into expensive metals like gold. They thought all you had to do was add mysterious chemicals and... ta-da! Huh? Nothing happened. Wait, that was the chemical for my invisibility potion. You can still see me. Good. Okay, so now you take a little sprinkle of this and turn the cheap piece of lead into priceless mess. For hundreds of years, people thought they could make gold out of cheap metals like lead, but it didn't work. Actually, Victoria, there's a lot of gold in the world, but it's usually mixed in with other stuff in very tiny amounts. In a gold mine, they mine tons of rock and take all the little bits of gold out of it. Another way miners find gold is by panning for it in streams. And that's today's My Great Challenge! All right, today my challengers are Zach.
Yeah!
And Brianna.
Woo!
You're gonna pan for gold like real miners. Also, Matt came in because he helped me build a stream.
Streams are a great place to find gold. Gold, when it washes out of rocks, is so heavy, it washes down streams and it sinks to the bottom and gets caught in the sands and the gravels. So then all you have to do is come and scoop it out. Look what I brought with me.
Whoa! Did you find that in a stream?
Oh, I wish. I had to chip this out of a rock. This is a mineral called pyrite, or fool's gold, and it looks just like gold. And it's even fooled some miners in the past.
All right, so we don't have pyrite for you, but we have actual real fake gold for you to find. Are you pumped to find real fake gold?
Yeah! We're gonna get fake rich!
All right, take your positions. You'll have 2 minutes to pan all of this water and find as much gold as you can. The one who finds the most gold will be the winner. Are you ready?
Yeah.
3, 2, 1, go! That's right, guys. Swirl that water around and find the gold. Getting a lot of sand there, Brianna.
Swirl, swirl.
I need water. It's cold. It's cold.
You really need to get a lot of water so you can
yeah.
get rid of the sand, right? And find the gold.
That's right.
Brianna's got some. She's off to a great start. She'll be fake rich in no time. And Zach has some too, but he's got some catching up to do. Remember, the more you swish, the more you can fake rich.
That gold is super heavy. It's always at the bottom of the pan. Get more, get more, get more water. Keep going, keep panning. More water, that's the trick.
Brianna's looking for that buried treasure.
Look at that.
Zach's got some more. He might be catching up. Brianna likes to dig through the sand to find her gold. Zach has a different way of doing it. He likes to swirl the water around.
It's all technique.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Time's up.
Oh, I had this. That's not even gold. Oh, yes, it is. Oh, well.
So close.
You dropped it.
All right, let's see who got the most gold. Zach, let's weigh yours. 11 grams.
Whoa.
How much would that be worth if it was real gold?
That's like $500.
My precious.
And Brianna, let's weigh yours. 26 grams.
Whoa!
That's like $1,100 of real money.
You're the winner.
Yes!
Congratulations. But I guess you both win because you get to keep the real fake gold.
Okay.
So would you guys like to do this all day for your job? Pan for gold?
No, thank you. Because then I just keep it.
And then it'd be real gold, right? Yeah. Thanks for playing. Now here's a question from Joseph.
How do rocks grow?
Rock-a-bye, baby rocks. Come on, little baby rocks. Grow! Grow!
I've been watering these rocks for days now, but still nothing. I bet you think this is silly, but there really are types of rocks that do grow. Can rocks grow? To find out, I'm going deep inside some caves. And to show me around, here's Riles Forest. Hey, Riles.
Hi, Harrison. You excited to go caving today?
Yeah, so where are you gonna take me?
Trevor and I are going to show you through Riverbank Cave, which is the deepest cave here at Horn Lake. Let's go caving.
Sure, but what about non-rocky things like bats or bears or something?
Don't worry, we won't find any, except for maybe some moths, cave crickets, or spiders.
I wonder if there'll be diamonds. Can rocks grow in there?
Yeah, we're gonna see some pretty cool different things. I'll show you. I think caving's really cool that you can go in a place that not many people have been in before, and you can explore different places and have crazy adventures sometimes. You never know what's around the corner.
This is a cool ladder. Woo! Ah. This is so cool. Wow. Can you see rocks growing in here?
All this white pretty stuff you see hanging from the roof and on the walls, you can always see them growing. It's called calcite. So it's when the water flows through the cave and then picks up bits of calcium. And the rock has the calcium because it's made of dead sea animals, their shells and bones. So when the water picks up the calcium and then drips from the ceiling, it'll leave a little ring. And then over years, it'll build up and then get longer and longer.
And that's like a stalactite, right?
Yeah.
Cool.
And then if it still has some calcium left, it'll drip onto the ground and form a stalagmite.
Stalagmite, stalactite. So how can you tell the difference between them?
Stalactites stick tight to the roof. Stalagmites might reach the top one day. Or C for ceiling, G for ground.
Cool.
And then when they connect, they form a column.
A column. So that would be from like the floor all the way up to the roof.
Yep.
It doesn't look like they're growing right now.
But they are. They grow 2.5 centimeters every 100 years.
Wow. That's not very
And
that's
that's
not very
the
fast.
fastest one.
Oh, that's the fastest one?
Yep.
So we won't be able to see them grow with our eyes.
No.
Still really cool.
There's also lots of other calcite formations, like draperies, bacon strips. There's a cave crocodile. A cave wolf. It's amazing, all the different ones.
Yeah.
I got one other cool thing to show you. Come on.
Cool. There we go. There's water!
There's water! Waterfall water. Yeah, so this formation we're coming up to is called the Ice Cream Waterfall. It's actually 3 stories tall.
Wow, this is so cool. Oh, and it looks like there's diamonds.
Don't touch it. If you touch it, it'll kill it because calcite is like crystals, kind of. So when the water flows through with the calcite, it'll catch on the crystals and keep building up bigger and bigger. But if you touch it, it'll break them down, and the oils from your skins will break them down. So if you touch it, it can't grow anymore.
Oh, that's no
You
good
pretty
then.
much kill it.
Oh no. The crystals look a lot like diamonds. Are you sure they're not diamonds?
I'm sure.
Is there diamonds in caves though?
Some caves in other parts of the world, you can find diamonds, but not in these caves.
Darn. So you wouldn't happen to know how to squish coal into diamonds, would you?
No, sorry.
Darn. Well, thanks, Riles, for being on my show and showing me all these cool caves.
Thanks for being interested into caves.
Oh, and I know one more thing that caves and rocks are really good for. Having fun. So it turns out that rocks really can grow. And that's the subject for today's The Experiment. I'm going to see if I can grow my own rocks the same way they grow in a cave. I have 2 jars of water here in which I am dissolving Epsom salts. Then I'm taking this string with 2 weights attached to each end so that it'll sink to the bottom of each jar. Then I'm gonna slide this plate underneath and wait. As you can see, a week later, I've grown some stalactites and the start of some stalagmites. Pretty cool. Going to the caves with Riles was pretty fantastic, but I still want to turn coal into diamonds. So I'm trying to squish it using these elastic bands. And in a minute, I'll reveal it and then answer the question that started me on this rocky road.
When you squish a piece of coal, how does it turn into a diamond?
Well, Benjamin, the big answer is... it's just coal. Sorry, Benjamin. But if there's any way to turn this into a diamond, I bet I know who can tell me. Hey, Matt, I have a question.
Yeah, sure, Harrison.
I was trying to make diamonds out of this coal because I heard people can do it, but I couldn't do it.
Well, it takes a lot more than rubber bands and hope to make diamonds out of coal, Harrison.
Surprise! Matt says that most diamonds are not made from coal. They're actually made from other kinds of carbon material, deep underground under very high temperatures and pressures. But now, scientists have found a way to make them in special labs.
The way they do it is they take carbon, like coal, and they heat it and they squeeze it at tons of pressure and heat, and they try to simulate the same conditions that we see in nature.
And voila, man-made diamonds. Are synthetic diamonds like that worth as much as real diamonds?
No, there's no replacement for nature.
Well, thanks for helping me find stuff out, even though you couldn't help me make a fortune in diamonds.
No problem. Well, let me give it a try.
Sure. What? How did you do that?
Magic hands.
It's gone.
Rock on, Harrison.
Wow. Hey, Rocky, check out what happened at the cave.
So just remember, if you're going down and you kick a rock down, just remember to yell, "Rock!" so that everybody below you knows not to look up when the rock's falling down.
Hey, you know what? This is really cool. This rocks. This rocks.
What? Rocks?
Sorry, I was just getting really excited about the rocks.
Oh, okay.
See you next time for more finding stuff out.
There's a crazy thunderstorm outside right now. And there goes the power, which is totally okay because I'm not afraid of the dark, like, at all. I wish I could light up like these glowing stars. I could be my own nightlight, and then the darkness wouldn't get me. That is if I were afraid of the dark, which I'm definitely not. Hey, speaking of being my own nightlight, here's a great question I got from Aiden.
If fireflies glow in the dark, why can't we?
Yeah, why can't we glow like a firefly? I've never actually tried to glow. Maybe I just have to concentrate. Nothing's glowing. Why can't we make our own light like fireflies? Or like comets? Or lightning? I don't even know how we make electric lights. But maybe your questions about things that light up will help me find an answer by the end of the show. A good place to start is to find out more about creatures that know how to glow. Here's another question about fireflies. This one's from Sean.
Why do fireflies' butts glow?
I checked, and I found out that fireflies' butts light up for one main reason: romance. I found out that fireflies have 2 special chemicals in their bodies, and when they mix together, they create light, kind of like a glow stick. They can control these chemicals to turn their light on and off whenever they want. Different kinds of fireflies can make yellow, green, orange, or even blue light. They actually talk to each other with patterns of flashes from their butts, like secret code. The male fireflies flash a message to say,
"Hey, I'm a certain type of firefly, and I'm going to tell you a little more about myself."
And if a female likes what she's seeing,
they'll flash back. Then the male follows her flashes and flies over to meet her.
How romantic.
What a great way to find each other in the dark. Actually, they're not just sending sappy messages. Their flashes can also warn hungry predators to stay away because they taste really bad.
We might not be able to glow, but we can use lights to communicate like fireflies do. Ooh, I bet my friends know some ways that we use lights.
Ask a friend. A police car has a red light on top which says "Get out of the way."
Lighthouses shine light on the rocks, then the ships could see the rocks and then they would turn back.
Like when we're driving and we see the lights says green, red, and yellow.
If you flash lights in specific ways, like turn it off and on, I think it can be Morse code.
Holy moly, you're right. We use flashing lights to communicate all the time. Hey, wouldn't it be funny if we did all that with our butts?
You know, just like fireflies.
It's the police! Come out with your hands up! If you could make any part of you light up like a firefly's butt, what would it be?
It would be my wrist, probably my nose. Somewhere on my face, like my eyes, my nose, or my mouth.
My nails for like Halloween parties and stuff.
I think I would want my head to glow so people can see my face.
Ooh, yeah. You could be a ghostly floating head in the dark. Ooh. This next question is from William. Ooh.
Do some fish glow in the dark?
Do some fish glow in the dark? Well, I checked. And on land, there aren't too many animals that can make their own light. But underwater, it's a different story.
To find out more, I swam to the darkest depths of the ocean. Not really. I'm actually in the very dark laboratory of Dr. David Morse, a biologist who specializes in glowing sea creatures.
Whoa, what is that?
This is a flask of dinoflagellates.
Huh, it glows.
Oh, hello.
Hi, Zoe.
That looks like plain old water in there. How come it was glowing?
Well, it's not plain old water. It's actually full of creatures, and they're really amazing because they produce their own light.
I don't see any creatures.
Well, they are so small, you actually need a microscope to see them.
Wow. Incredible. But why do you have to stir them up to make them glow?
They're sensitive to movement, like somebody swimming in the ocean or a predator swimming after them and trying to eat them. And their response to that movement is to give off a flash of light, either to scare away those predators or to attract predators of the predators.
They use the light to communicate to the predators of their predators?
That's right, but any movement of the water will make them give off light. There are places where the beaches glow at night with the waves, and the water lights up. It's really beautiful.
Amazing. Can I see one close up?
Sure.
Wow. All those creatures were in that water?
Yes, and they even have tails to help them swim.
They're so cute. How do they make that light?
The same way that fireflies do. They burn a molecule called luciferin, and that produces the light.
Cool. Are there any kinds of fish that use light to communicate?
Lots of them. In fact, most of the fish that live in the bottom of the sea are bioluminescent.
Dr. Morris tells me that bioluminescence is the chemical reaction that makes some creatures produce their own light.
It's very vast and dark in the deep sea, so the creatures there use light to find and signal their mates or to lure in their prey.
Cool.
Did you know that some animals can actually scare off their predators with bursts of light? And others can hide by lighting up their bellies to perfectly match the light coming down from above, so their predators can't see their silhouettes.
Which way did he go? Holy cow! There are so many fish and other sea creatures that can glow in amazing ways. Hey, can I keep some dinoflagellates as pets?
Sure you can. I put some in this tube for you. All you have to do is put them in the sunlight every day, and then they'll light up at night.
Cool. I'm so excited. I'm going to name them all.
I should tell you there's probably about 1 million in there.
1 million? Now I have to think of 1 million names. Okay, I'll name you Sparky, you Twinkle Toes, you Lightning, you Thunder.
This could take a while.
You Twilight. Boy, I'm going to have to think of a lot of names. Meanwhile, here's another question about glowing animals from Deborah.
How come a neon fish will glow at night when you shine a bright light at them?
Well, Deborah, I checked. And some animals don't make their own light, but they're really good at reflecting it. Neon fish have crystals in the skin underneath their scales that reflect light. Kind of like the reflector on your bike. But without light, you can't see them. And check this out. Some fish reflect light in an extra cool way, by changing color. It's called biofluorescence. These fish live in the deep, dark ocean, where only blue light gets through. When that blue light hits them, it's reflected as green or red light. That's because biofluorescent fish have special colored lenses in their eyes, kind of like sunglasses. They stand out like a light bulb in the dark, and that's how they recognize their own kind. That gives me an idea for... My Great Challenge! I have here with me Jeremy. I'm going to call you a squigglefish.
Yeah!
And Molly, I'm going to call you a splatfish. Yes! You each have different hidden patterns on your arms that you can only see with these black lights. That's kind of like using the special eyes that some fish have for finding the hidden reflecting colors of their mates. You get to do almost the same thing in this challenge. Use your black light to find the biofluorescent fish with your pattern on it. Oh yeah, and some fish have no pattern at all, just to trick you. Your challenge is to find as many fish of your own kind as you can in 2 minutes and take them back to your home base right here. Are you ready?
Yeah!
Then go find your fishy matches. The one who gets the most fish wins. Squigglefish found a pattern right away, but it's Splatfish's pattern.
I keep on finding them that don't match.
Splatfish looking for a pattern. Yes, it checks out. That's one for Splatfish, but Squigglefish has one too. And Squiggle gets another right away. That puts him in the lead, 2-1. Squiggle looking for another match and finding it. Get moving, Splatfish. So far, Squigglefish has 3, and Splatfish catching up now with 2. Splatfish gets another one, but so does Squigglefish. The deeper you go in the ocean, the bluer and darker it is. That's why biofluorescence is amazing. Animals that can make these colors and patterns light up brightly can use them to see each other in the dark, avoid predators that can't see them, and find a mate to have babies with. Only 10 seconds left!
Can't find any more.
Can Splatfish catch up? Oh no, this fish has no pattern. It's not bioluminescent. Splatfish is wasting her time. Okay guys, time's up. So Molly, you have 5 points.
Yay!
And Jeremy, you have 6 points.
Yes!
So you win. And now, time for a blackout party. This is almost as much fun as this question from Andeline.
Why does a comet have a glowing tail?
Flat Earth Corner!
No. This is a terrible sign. That devil star will bring us nothing but earthquakes and plagues of sickness. The rain will turn red with blood, and animals will be born with 2 heads. Run for your lives! And while you run for your life, do it in style with these Devil Comet t-shirts and buttons. Or commemorate the end of the world with a pendant. I've got every souvenir for the comet apocalypse at low, low prices.
Pretty much every ancient culture in the world dreaded seeing a comet in the night sky.
I found out that they thought the comets were sent by gods to bring war, illness, and destruction, and every bad thing you could imagine.
Luckily, thanks to science, we know a lot more about them now. In fact, I've got some experts who are going to help answer your question, Andelaine.
Please welcome astrophysicists from the McGill Space Institute, Robert and Gabrielle.
Hi, Zoe.
Hi, Zoe.
Hi. Wow, what is this?
This is dry ice.
We're going to use it in a minute to make comets.
Cool.
It's actually extremely cold.
Wow.
Okay, so here are all the ingredients we need to make our very own comet.
Like a comet cake mix.
But I certainly wouldn't want to eat these cakes.
Most comets have dirt and they have dust in them. So we're gonna use the sand here and the dirt and we're gonna mix it in the bag. And you can do the same with the dirt now.
So we mostly think of comets as dirty snowballs in space. So we already have the dirty part, but for the snowball bit, we're gonna use some water. So now we have pretty much a mud pie. Now we need to make it into a comet. We're going to use the dry ice we found earlier to freeze our comet. And we don't want to freeze our hands. We have some mittens to put on. So I'm just going to add a few scoops of this. There we go, and one more for good measure. Okay, so you want to push that all to one side of the bag?
I can help. We can take the comet out of the bag and look at it.
Wow, it looks like an ugly snowball.
And that's exactly what comets look like when they're really far away from the sun.
So, how does it light up?
If you were to blow on the comet...
Wow.
You see, it's producing a tail.
That's just like what happens when a comet gets close to the sun. It starts to melt, and it leaves behind a big, long vapor trail. The sun pushes the vapor trail away from the comet and gives us the big tail we see in the sky.
Oh, so the comet's tail always points away from the sun. But what makes it light up?
It just reflects the light of the sun.
Oh, I get it. It's the same way the moon shines.
Exactly.
Well, thanks for being on my show.
Thanks for having us.
I have another question from Andrew about lights we see in the sky.
Why is lightning so bright?
I checked, and I found out that the big flash of light is created by electricity that builds up in the clouds. It's kind of like what happens when your socks stick together when they're tumbled up in the dryer, and you try to pull them apart. They zap. Check out this cartoon I made. Tiny pieces of ice form high up in the sky, where it's really cold. These ice crystals turn around in the wind, and they bump against water droplets and other ice crystals. As they rub and bump into each other, they build up an electrical charge. Eventually, the charge builds and builds to form a gigantic spark. The lightning's bright flash comes from that spark. Did you know that a bolt of lightning can give off as much light as almost 17 million light bulbs at once? That's a lot of light bulbs! Uh-oh, do try this at home! Emerald and Linnea are going to show you how to make your own mini lightning with just a balloon and a spoon. Here's what you do. Rub the balloon on your hair till it gets good and staticky. You'll know it's ready when your hair stands up and sticks to the balloon.
I think it's ready.
Then in the dark, bring a spoon close to the balloon.
Oh, there's a little spark.
Wow, did you see that? It's tiny lightning.
Bye, Zoe.
Nature has some cool ways to make light. What about us humans? Here's a question from Andrew.
How did people see in the dark when there was no light?
Tired of dark when day goes away? Try new fire stick. It light up your life. Invention need work.
The first thing humans used for light was fire. But it's dangerous and burns out really quickly.
But I found out that eventually we learned how to make it burn slower. We burned moss soaked in animal fat, which led to the first oil lamp. After that, we made candles out of wax. But when we figured out how to capture and control nature's electricity, everything changed.
This is a perfect time for Sophia's question. How do you make a light bulb?
How do I make a light bulb? Ding! I asked my scientist friend, Shakib, along with Daniele and Andrea.
He knows how Thomas Edison made the first really useful light bulb back in 1879.
It's important to do this with an adult because it can get a little bit dangerous. Andrea here is going to help me. So what I need you to do is take this toilet paper roll, tape my 2 alligator clips to the side of that. And Daniele, I'm going to have you use our thin piece of filament here, which is actually a piece of picture wire, and attach it onto our alligator clips. And now I want you to cover it with this jam jar that I cleaned out earlier. The last thing we'll need is some electricity to send through the filament so that it glows. I have a battery pack here. I'm going to connect. What do you guys see?
Fire, light and burning.
Yes, we made a light bulb.
Cool.
Yeah, that's for sure.
Uh-oh.
Wow, did you guys see that?
Yes, it just burned.
The filament's completely gone, but we do have a way to make the filament last longer. What's in the jar, you guys?
Air.
Very good. So if we remove the air from the jar, we can actually make our filament last a little bit longer and have a better light bulb. So we've got a candle here, put that in here, and we have to attach a new filament. And what we're going to do with our candle is light it. So a candle requires a couple things to burn. Of course, it needs the fuel, which is the wax that we have in the candle, but it also needs air or oxygen to burn. If we use the jar and we cover our candle, what will end up happening is we won't have any oxygen left. Can you see that the candle flame starts to get a little dimmer?
Yeah.
And then it goes out and we get a nice puff of smoke. So then we know there's no oxygen left inside our jar. And I'll just connect the other clip here. And look, this time it lights up, but it doesn't burn because there's no oxygen inside. Edison tried a whole bunch of different filaments for his light bulbs, but it wasn't until he removed the air and created a vacuum inside that he invented the electric light bulb.
And the rest is history. That was an awesome experiment. Thanks, guys.
Bye.
Well, when it comes to lighting up from fire to fish that glow, nature's had it figured out from eons long ago. But when we use our brainy minds to follow nature's lead, we use the things around us to create the light we need. Oh, we made oil lamps and torches, fireworks and candles, lanterns, light bulbs, luminescent lights on our bike handles, neon signs, glow sticks, laser shows and movies, traffic lights, this lightning thing. These flashy shoes are groovy. There's headlamps, pyrotechnics, lit up fair rides, computer screens, holiday lights, lighthouses.
You're gonna make my head explode!
Phew! We've harnessed light to do so many amazing and silly things. But I still can't get my own butt to glow like fireflies. No fair! And that brings us back to the question that started off the show. If fireflies glow in the dark, why can't we? The big answer is... we actually do. Well, not enough to see with our eyes. Only just a tiny, tiny amount.
I found out that all living creatures give off a very small amount of light because of the activities of our cells. We humans have never been able to make our own light on purpose, though, the way cave worms and deep-sea fish do. That's because we don't live in constant darkness.
But we were smart enough to figure out how to make the light we need with stuff we found in nature. Which means...
Hi, welcome to Finding Stuff Out, the show where you send me your questions and I search for the answers. Today, I'm trying to make a fire to heat up this soup like our ancestors did thousands of years ago.
How hard can that be?
I've been at this for a while now, and I'm not getting anywhere. So instead of making fire, I'm just getting sore wrists. It's time for a break, and time for our first question.
Why, when you get older, stuff will change?
Yeah, Tristan. Why does stuff change when you get older?
Everything's
different now. It's all changed. When I was a young lad, things are really different.
Oh wait, I still am a young lad. Ouch! I think they make glue stickier than they used to. People are always changing the tools they use to help them go about their lives. So I don't know why things change, but by the end of the show, I'll have the answer. Here's a question.
In the old days, did they use robots to milk cows?
I wonder. To answer your question, Adonijah, please welcome my special guest, Dr. Michael Bisson.
Hello.
So you've brought a friend of yours.
Yes, it's a Neanderthal. He's 70,000 years old.
Must be an old friend.
Yes, it is.
So they had robots back then to help them milk cows, right?
No, I'm afraid robots were only invented within the last 100 years, and most of them within the last 50 years.
Dr. Bisson says that in the old days, they milked cows by hand.
And the big advantage of human hands is that they're very different from animal paws. Humans have fingers and a thumb that can touch the tips. They're opposable, and they can make the actually fairly complex motion necessary to milk cows.
So Adonijah, while they didn't have robots when we started milking cows about 8,000 years ago, humans did make tools for doing a lot of other things.
And a robot is a very complex type of tool. The earliest tools, however, were very, very simple.
So I see you brought some of these tools with you today, right?
We brought everything from very early tools, over 1 million years old. This is a hammer, and this was used to break nuts, to break into bones, to get at the marrow, just anything that required pounding. This is what's called a hand axe, and this was probably used to dig, to break through clay soil to get roots and other things that could be eaten. These two are the all-purpose heavy-duty cutting tools. By that time, they're hunting very big animals.
Dr. Bisson says early humans became much stronger than us because they hunted those big animals with very primitive weapons, like this wooden spear.
This is an exact replica of a spear that's 400,000 years old, and it was found with the bones of mammoth, of rhinoceros, and of horses. These tools are made by Neanderthals, by our friend here, and they are around 50 to 200,000 years old. This is a scraping tool. It's used to work wood and to scrape the fat layer off of hides. Around 30,000 years ago, Stone Age people started to make use of handles regularly. Adding a handle like this gives you mechanical advantage, allowing you to use this little scraper much more effectively than, say, this big Neanderthal scraper. So this little scraper could actually get more done more quickly than this could.
Wow.
Would you like to learn how to make a stone tool?
Sure.
Hold it and try to strike right there.
First, I had to use this smaller rock to break a piece off this bigger rock.
Yes.
Whoa.
You're natural. Good. So would you like to turn this into a scraping tool?
Sure.
Here we have a piece of bone. This is actually the antler from a moose. And you're going to take this piece and strike it along the edge and take off chips.
Make it sharp.
It's going to actually make it a little bit duller because when you're scraping a hide to clean the fat off it, you want a sharp edge, but one that's not too sharp, because if it's too sharp, it'll cut a hole in what you're trying to turn into clothing or something like that.
So like
and
that.
Here you want it on this side and at about that angle.
So like?
Yeah, very hard.
Oh yeah, all the edges are coming off now.
Perfect. So yeah, quit right there. You've got it. That's exactly the edge you want. So you've just made a Neanderthal tool.
Yeah!
Congratulations, you're a Neanderthal.
Congratulations!
Here's another question Michael can help us with. It's from Olivia.
What did caveman write with?
Yeah, what did cavemen use to write with?
Cavemen actually didn't write at all because there was no written language. There was also no paper to write on. So they did, however, paint, beginning about 30,000 years ago, painted the walls of caves, possibly painted their clothing, possibly painted their bodies.
So what did they make paint out of?
They made paint out of natural things, out of clay, out of charcoal, and out of certain types of stone that when you crush and grind it, produce very bright colors. Here's a piece of iron ore. Try to draw something on that paper with it.
Oh yeah, it's like brown sort of.
It's a reddish brown, but notice you can hardly see anything.
Yeah.
Well, just a moment. When we take this piece and grind it on another piece of stone, it produces a red-brown dust that can be turned into paint.
But how did they get it to stick to what they were painting?
Water can be used sometimes, but also animal fat. And we don't have any animal fat here, but we have lard, which is a good substitute.
Okay.
So we'll just take a little bit of lard here. And I ground up some of the iron ore last night in this very small amount.
So that's iron ore?
Took more than an hour to grind, so this is a very long process.
More than an hour?
Yep.
Wow.
And then just mix it.
Oh, now it's like a paint, like it's wet. And...
It's an actual paint.
Cool.
And this is the sort of thing that they use to paint cave walls.
Ah. This looks like a cat's tail. Did they use fur as a paintbrush?
Yes, it's possible. No brushes have survived from that long ago. There we go. A prehistoric smiley face. Excellent.
So, thank you, Michael, for being on the show.
It's been my pleasure. It's been a lot of fun.
It was.
My question is, who invented everything?
The Flat Earth Corner! Humans will never be able to fly. If we were meant to fly, we'd have wings. I heard someone say that they believed that signals could be sent through the air. That's just crazy! And being able to talk to each other on some gizmo? Silly! And some people say you'll be able to record music and then listen to it later without the musician even being there. What poppycock! And other people think that one day we'll be able to watch some box in our home and see other people performing in shows. What, like this? That's the most ridiculous thing I've ever heard. Don't you agree? Hey, what is that and who are you? Hey, how did you do that? There's always been people who say that new inventions are impossible, but then there's always people that disagree. Alexander Graham Bell invented the telephone. The Wright brothers created manned airplanes. Guglielmo Marconi invented the radio. Thomas Edison perfected the light bulb and invented the gramophone, which was the granddaddy of the CD player. All of these things that changed our life so much were created in the last 150 years. Now it's time for you to think like an inventor. Uh-oh. Do try this at home. We're gonna see what we can do with just one sheet of paper like this. Listen up, gonna tell you about my paper wrap. You can use this for a fan or for a cap, a secret message plane that you can throw, a listening device to spy on your bro, a megaphone or a basketball. With one sheet of paper you can do it all. With one sheet of paper you can do it all. Now it's your turn to give it a try. In this story, the king, hello, I'm the king, is trying to get back into his castle. But there are some obstacles in the way. So to help him get back into his castle, I'm going to use one sheet of paper to make 3 simple machines. There's a highly scientific explanation for why they're called simple machines, and that's because they're machines and they're simple.
Very funny, Mr. Smarty Pantaloons.
Hey, kidding. But they help us make amazing things, like the first one we're going to make, a lever. So, roll up your paper like this, then find something that you want to move, like these boulders that are set up in front of the castle.
Who put these boulders in front of my castle? How am I supposed to get in?
Normally, the king wouldn't be able to move these boulders by pushing on them. But then he sticks one end of the wedge under here and places something under the lever for it to rest against. That's called a fulcrum. And guess what? Presto! One boulder out of the way.
Hey, that's pretty cool. Yeah, I'm the man.
Here's another kind of lever. Those gears look complex, but they're really just a series of levers too. Now I need to make a different device to help my king get back home.
Hey, what's with the bricks? Who put those there?
So fold your sheet of paper like this, lengthwise in half, then in thirds, then fold it again, like so. You get a wedge. Even though this wedge is only made of paper, it's strong enough to push these bricks apart.
Whoa, how neat was that?
Just think of how much more force it could have if it was made of something like this. Now our king just has one last obstacle to overcome. The door to the castle is locked shut.
Ah, I forgot my keys.
Fortunately, there's a solution. Take your paper and fold it lengthwise until it's strong enough not to bend. Congratulations, you've made an inclined plane. This tool makes it possible to move objects upward with the least amount of effort.
Well, that's more like it. I can walk up to the top of my castle walls and whoa! Guess I should have put one on the other side too.
Here's an example of an inclined plane that you have probably seen. Here are ideas for tools that other kids would like to invent.
If you could invent anything in the world that's new, so nobody's made it before, what would you make?
A rocket skateboard.
Some sort of shoe that could do anything that you want.
I would make a flying car.
Probably edible tape. A helicopter with airplane wings that can go back in time.
A hockey stick that could shoot 2 pucks at once.
Maybe flying shoes, I don't know.
If you could invent anything in the world that hasn't been invented yet, what would you make?
Rainbow popcorn.
Harrison, I think I've just come up with an idea for the perfect invention. Edible, flying rocket shoes. They can make rainbow popcorn, go back in time, and shoot 2 pucks at once.
What did cars look like in the old days?
The short answer is like this. Okay, it's not a car the way we're used to seeing it, but up until just a little bit more than 100 years ago, this is what a car was. It comes from the ancient word kara, which means chariot. Now, they might not have had engines, but they were quite exciting to get around in. Just ask these guys. Talk about Hot Wheels. As for the first cars that didn't come with a horse attached to them, they looked like this. Then this. Then this. And then this. And who knows what they'll look like by the time we get our licenses. Speaking of rides, here's a question.
Who made the first wheel?
I checked, and wheels are an ancient invention. Nobody knows who made them because it happened at least 5,000 years ago. They were probably first used on those carts we were talking about, but they're so handy that they're used on all kinds of things. Now it's time for My Great Challenge! Welcome to My Great Challenge. Today, our contestants are Emma and Marshall. Okay, you have your catapult here and you're gonna try to fling your monkey as far as possible. There's 5 positions on the catapult, and where you put your peg, or fulcrum, in the catapult lever will affect how far your monkey will fly. Your job is to try to catapult your monkey as far as possible, and you have 3 shots at this. Are you ready?
Yeah.
Okay, let's get started. Marshall putting his peg in the 2nd hole of the catapult, and Emma putting her peg in the 3rd hole. Marshall is gearing up for his first launch. Ouch! That monkey doesn't even make it to the grass. I'll put a mark where it landed. Oh, not too far. Let's see how Emma does. Emma preparing to catapult her first monkey. Oh wow, Emma. I'll just mark where that landed too. Now for Marshall's 2nd try. This time he's going for the 3rd hole. And Marshall gets even farther. Emma putting her peg in the 4th hole. So let's let Emma go her 2nd time. A little bit farther this time, Emma. Marshall chooses the 4th hole too. Even farther, good job. Emma has 1 more shot. She's chosen the 2nd hole. Oh, no. The best place to put the fulcrum was in hole number 4. Well, it looks very close, you guys, but I think Marshall's the winner. Yay! Congratulations.
What was the first house to be made?
So let's see. Like Michael, the archaeologist, said, our ancestors didn't start making tools until about 2 million years ago. And then there's cave kids and their parents who didn't even know how to make paper to paint on. And wasps have been around for millions of years, since the time of dinosaurs. And they built houses out of paper that they make. Animals that knew how to make paper before humans did, millions of years ago, when dinosaurs roamed the earth. Ah!
You're gonna make my head explode! It's true. Long before there were any humans at all, wasps made houses using paper. Paper is something we learned how to make only very recently. But wasps don't need tools to make paper. They can do it with their own bodies. But if you're talking about the first houses humans made using tools, they were probably like this. Early humans used stone tools to prepare animal skins and wood and bones to build their houses. I'm glad that's changed.
I wouldn't want a dog to walk off with a part of my house. Now here's a question from Elijah.
Why do machines make machines?
To find out the answer to that, here's an experiment.
Presenting, why do machines make machines? Nowadays, machines do most of the work in building these machines, cars. They weld the body parts together and move all the heavy car parts that used to be moved by humans. Using machines, we can build a car from scratch in less than 20 hours.
So now we know after watching that video that machines can make other machines very quickly. But I'm gonna put robots to the test and see how quickly I can put parts on a car. Robots, stand back and see what humans can do. How come it won't go in? Wait, how did these even go in? Whoa. Don't worry, I'm just warming up. I'll show you robots how it's done.
It turns out that for some jobs, machines can do things faster than humans can. That means that some things, like cars, can be sold cheaper and more people can own them. And that's why machines make machines.
But can you do this? Well, we may not have reached a decision on who's the better dancer, but we have reached the end of my show. So it's time to answer the question that got this show started.
Why, when you get older, stuff will change?
The big answer to your question is... perfection. Yeah. It's human nature. Tools change very quickly. Take a look at these. Not one of them is more than 50 years old. That's younger than some of your parents. Look at this cell phone. Hello? Operator? Yeah, there's something wrong with my phone. It's too big! Look at this video game. It's one of the first ever sold.
More than 35 years ago, this was as exciting as it got in the gaming world. Good times. In the swinging 60s, this was the space shuttle of calculators.
Well, I never did get my fire to start, but fortunately, I have another way of heating up my soup. Ah, that's good. People developed ways of creating heat, like this microwave oven, because it's so much easier than rubbing sticks together. And that's why when you get older, stuff will change, because people are always looking for better and easier ways to get things done. And finding stuff out.
So, now I'm being like a cave kid, using fur as a paintbrush. Hold still, Mr. Whiskers.
I guess cave people never had to paint with cats. I give up. This computer animation stuff is way easier than trying to get that cat to hold still.
That's
utterly ridiculous.
See you next time for more Finding Stuff Out.
I'm wearing a bandage because I cut myself on a thorn bush when I fell off my skateboard last week. Ah! Ow! The last 2 times I changed my bandage,
it really hurt when I pulled it off.
It made me wonder the same thing that Adriana was wondering.
Why is there pain?
I don't know why there's pain, but by the end of the show, I'll find out. Meanwhile, I have to change this bandage again. I just hope it doesn't hurt as much as it did last time. On second thought, maybe I'll change it at the end of the show. Now here's a question from Julia.
Why when you get a bee sting, it gets all swollen and it hurts?
To answer that, I believe we should go to the king of stings, Dr. Justin Schmidt from the University of Arizona.
Dr. Schmidt has been passionate about insects ever since he was a kid. He's been stung more than 1,000 times, all in the name of research.
Dr. Schmidt?
Hi, Zoe.
What happened to your face? Is that what happens when you get stung too much?
Well, I tried to learn all about stings.
Professor Schmidt told me that when an insect stings you, it injects venom. And the swelling you get is an allergic reaction. It's your body trying to defend itself.
Bee stings are probably the most painful that you'll run into. Now, if you want to come to Arizona, we can get you some real good stinging insects.
Like what?
Well, right here, we've got some harvester ants. They're just little guys. They hurt for not just 10 minutes like a bee sting does, but they hurt for like 4 hours. Not fun.
They don't sound fun. So what else do you have?
Well, we have some velvet ants. They're not really ants, they're wasps. And they're kind of cool, they squeak. They hurt really intense.
So what did you do to find out which insect stings were the most painful?
Well, in the process of being a biologist, you often make a mistake. Uh-oh, bad idea, because then you get stung. You might as well get some good information out of that, what it feels like, how long it lasts. And that's pretty much how I ended up getting stung by 83 different kinds of stinging insects.
So what did you do after being stung by all those insects?
I realized that this was useful information.
Professor Schmidt told me that he invented a way of measuring pain from a bug sting that's used all over the world. A number 1, like a bee sting, is not too painful and only lasts for a few minutes. But a 4, like a bullet ant sting, super duper hurts and lasts for hours.
So why is your research about insect stings useful?
So we're trying to use stings, which can cause pain, to serve as tools. And we can cause the pain, and then we can try to see if we can block the pain with new medicines that we're making. And that makes all of us happier when we're not in pain.
Thanks, Dr. Schmidt, for helping me find stuff out about insect stings.
You're most welcome. It's been a pleasure talking with you, Zoe.
Bye. Now, here's a question about pain in your brain.
How do you get pain in your brain? Ugh.
The Flat Earth Corner! How to get pain in your brain? Here in 8000 BCE, doctors like me have solved the mystery. Headaches are caused by evil spirits stuck inside your head. But don't worry, using this state-of-the-art Stone Age technology, we pierce a hole in your skull to let the evil spirits out. Another satisfied customer. Hold still, this only hurts a bit, most of the time.
Thousands of years ago, people thought demons and evil spirits caused headaches.
In the past, people had strange ideas on what caused headaches and how to cure them. For example, tying a buzzard's head around your neck, or rubbing molasses and cow poop on your temples.
Nowadays, we know that headaches aren't caused by demons.
Now you tell me? I found out that it's not actually your brain that's hurting. It doesn't have any pain receptors, so it can't feel pain. But other areas in your head do have pain receptors and can feel pain.
Now here's a question from
Sabrina.
Why does some food burn your tongue?
Bah. Well, Sabrina, he's an expert on food that burn your tongue, and it looks like he has brought me some. Please welcome Lawrence Isaac.
Hi, Zoe. I brought you a present.
But they look like hot peppers.
They are hot peppers. I figured we could try some. I hope they don't burn you too much.
You make it seem so appetizing, but okay. Hey, it didn't burn me.
So why didn't that hot pepper burn?
It's actually because that one was one of the milder peppers. Every pepper's got different heat levels, which is measured in Scoville units. It measures the amount of water you need so that you don't taste the pepper anymore. Different peppers, different amounts of water. So the milder ones take less water to dilute them, and the spicier ones can take up to a swimming pool of water to dilute them.
Cool.
So for example, here I brought some sauces. This one would take, for every milliliter, about 1 liter of water to dilute it completely. That one's called a poblano pepper. It's not too bad, right?
No.
Now, if it was really spicy, what you would do is you could have either some yogurt, some milk, or some honey, because the fats in the yogurt or the milk cut the feeling of the heat, and the sugar in the honey would cut the feeling of heat too. So the second one I'll make you try is jalapeno. So this one is about 6 times spicier. So instead of 1 liter of water to dilute it, it would be about 6 liters of water. How's that?
Oh, that's spicy!
Do you want some milk?
Yeah. Ah, much better. So what about the last one?
This one is made with ghost peppers. This is one of the spiciest peppers on earth. So 1 drop of this would take about 140,000 liters of water to dilute it. It's very, very spicy. You want to try this one?
I'm good. You can try it, though.
Okay, I'll try it. So right now, my mouth is watering. I feel like I'm gonna start sweating a little bit. Compared to the first one you tried, we're talking a lot more intense.
So why are peppers hot?
Because they don't want to be eaten. They have capsaicin in it, which is a chemical that fools our body into thinking it's hot. So they've developed this way of protecting themselves in nature from animals.
Well, it didn't really work because we still eat them.
That's true. Basically, what we've done is we've learned to adapt to it so we can handle the heat. And we even add it to our cooking, and it makes our cooking a little more fun.
Well, thanks for being on my show, Lawrence, and helping me find stuff out about how some foods hurt your tongue.
Thanks for having me, Zoe.
Why do some people feel pain more than other people? To answer that, I came here, to the Shriners Hospital for Children Canada, with my older brother, Jaden. Hey, everybody! He's agreed to be embarrassed by letting everyone see that I can stand more pain than him.
No way.
Well, I guess we just have to find that stuff out, won't we?
Hi, kids.
Hi! This is Dr. Catherine Ferland. So, can you tell everybody what you do here?
I help physicians, surgeons, and anesthesiologists to minimize the pain experience of children undergoing surgery.
How do doctors reduce pain?
So we treat patients with medicine.
Dr. Ferland told me that to find out how much medicine to give kids, they do a test to see how sensitive each one is to pain. And we're about to take the pain test.
Are you ready?
I'm gonna beat you.
No, you aren't.
My pain tolerance is way higher than yours.
No, it isn't.
You go first.
No, you go first.
No, you go first.
So we will start with a test to identify your pain threshold to heat sensation. This is a probe that generates heat. Okay, nothing to burn you. Don't worry about it. Touch it.
Warm.
It's getting
Yeah,
warm.
it is warm.
Yes. So you will feel it. The temperature will rise.
Yep.
And then you will start to feel pain. And then you will start to feel like you
More
can...
pain.
Yes, more pain. And then you will arrive to your tolerance threshold.
Yeah.
And then you say stop, and the test will end. Okay, so Jaden, you will have to leave the room.
Okay. Have fun,
Bye.
Zoe.
Thanks.
I'm still gonna beat you.
Okay, we'll see you.
So this is the pain scale, so from 0 to 10.
The temperature will get higher and higher. The one who can stand the highest temperature wins this part of the test. When I push the pain scale to 10, that means I can't take it anymore.
So it's starting.
Yeah, I can feel it's warm. Starting to feel a little pain.
Dr. Furlan told me that because pain is different for everyone, doctors need to know how much pain you can take to know what kind of medicine to give. They don't want to take all the pain away because not feeling any would be dangerous. For example, if you have a broken leg and don't feel it, you can make it worse by moving it too much.
Like, it hurts a little bit, but I'm still not at, like, 10. Almost at 10. Okay, I can't really stand it anymore.
Okay, we're done.
44 degrees was the most pain I could take. That's what Jaden will have to beat.
Okay, so now, Zoe, we will measure your tolerance to cold.
Ooh, is it cold? In this test, I have to keep my arm in icy cold water for 2 minutes.
How do you feel?
I would say maybe a 5.
5 on 10, okay.
I'm supposed to say how much pain I'm feeling using a number between 1 and 10.
How do you feel now?
Maybe an 8.
Oh, it's getting more painful.
It's pretty cold.
Whoever ends up with the lower number felt less pain and wins this part of the test.
And now?
Maybe a 10.
And we stop the test. Okay, so it was painful.
Yeah.
Ooh. Okay, Jaden.
Ow!
I haven't turned it on yet. You ready?
Ready.
Okay, let's start it.
Okay. It's getting warmer, and it's getting warmer. Oh, it's starting to hurt a little bit. It's about a 6. Whoa. Oh, that's too hot. Can you please stop?
Wanna stop?
Yep. Oh, it's so cool how it just stops like that.
Let's do it.
Whoa.
So how do you feel from 0 to 10?
4. It's so cold. I feel like I'm in Antarctica.
And now?
5.
So it's increasing, the pain is increasing. Again?
I think I would say 7. It's like...
Okay, the test has ended.
That was pretty awesome. I won because I'm the greatest, right?
I mean, you're the best, but I'm better than the best.
Only one best can be the best. Okay.
Hi, so I have the results.
Okay.
Ready for this?
Bring it on.
So for the warm test, Zoe had the highest pain tolerance.
Okay. Jaden's pain tolerance is at 39 degrees, and mine is at 44 degrees.
For the cold test,
I aced that one.
You did.
Jaden said his pain from the ice water was only 7, but I felt like mine was a 10.
So you have differences in your threshold, meaning that different types of pain, you react differently.
Oh, that's cool.
Well, Dr. Furlan, thanks for being on my show and helping me find stuff out about pain, especially that I can take more than my brother can.
Actually, it was a tie, but whatever.
Why do small boo-boos hurt more than big ones?
The cut on my finger from the thorn bush when I fell off my skateboard hurt way more than the part when I landed on my butt, even though my finger's a lot smaller. How come? This calls for an experiment.
The experiment! Emma is blindfolding Marco to demonstrate that some parts of our body are more sensitive than others.
So how many points are there?
2.
Marco has to guess how many skewer tips are poking him.
How many points are there now?
1.
How many?
2.
Now they'll try the same touch test on a different part of the body.
How many do you feel?
2.
Now how many do you feel?
1.
Now how many do you feel?
1.
It's 2. How many do you feel?
2.
It's just 1.
Okay, now the shoulder.
1.
Nope, there are 2.
Check out this funny picture of a human. It's meant to show where we feel things the most. The bigger body parts are the most sensitive, like our lips, tongue, and our hands. That's why Marco could feel the points pushing more easily on his finger and on his foot or his arm.
Uh-oh, do try this at home.
When you get hurt, do you ever have the urge to rub the part that hurts?
I found out that rubbing where you were hurt really does reduce how much pain you feel. If you get your fingers slammed in a door, shaking your hand also helps. All this rubbing and shaking activates nerves that help block pain. Just don't smash your hand when you're shaking it around. Ow!
All this pain relief gives me an idea for...
My Great Challenge!
I'm Dr. Zoe, and today on My Great Challenge, I have two challengers, Gamu.
Hi.
And Emanuela.
Hi.
So today's challenge is about pain. Gamu, what was the most painful thing you experienced?
I was skateboarding and then I slipped and banged my head.
Emanuela?
I was walking and I missed a step and fell in my pool.
You guys really have big experience with pain. But your job here is to help your patients avoid pain. So I'm gonna ask you some multiple choice questions and you'll have to answer with A, B, or C. Are you ready?
Yeah.
Okay, Gamu. Your patient has a terrible migraine headache. Do you A, drill a hole in their head to let the evil spirits out? B, have them brush their hair with an electric hairbrush to relieve pain with magnetism? Or C, give them headache relief medicine?
C.
I feel better.
You're right. Your turn, Emanuela. So your patient has fallen off their scooter and bruised their butt. How do you lessen the pain? A, with heat, B, with an ice pack, or C, with some really funny knock-knock jokes?
B.
I feel better.
You're right. Question 3. Your patient pulled a muscle while playing leapfrog. How do you lessen their pain? A, with heat, B, with an ice pack, or C, treat the area with snake oil?
B.
Ow! Sorry, Gamu. It's wrong. Okay, Emanuela.
A?
I feel better.
You're right. Heat is better than cold to soothe sore muscles, while cold helps injuries like scrapes and bruises. Okay, Emanuela, your patient has banged their hip walking through a doorway. Should they A, gentle rub it, B, apply leeches to the area, or C, hang a buzzard's head around their neck?
B.
Apply leeches to the area?
Ow!
Sorry, that's wrong. Gamu?
A.
Gently rub it?
I feel better.
That's correct. So you both have 2 points. So this last question is a tiebreaker. So Manuela, your patient has been stung by a jellyfish. Do you relieve their pain by A, washing the area with salty seawater, B, putting fresh water on it, or C, putting calamine lotion on it?
C.
Ow!
Sorry, that's wrong. Okay, Gamu, this is your chance to win.
A.
Washing the area with salty water?
I feel better.
That's correct. You win the game. High five. Washing the area with salty seawater actually deactivates the stinging cells. But if you put fresh water on it, it actually makes it worse. Hopefully it wasn't too painful of an experience. Thanks for being on my show.
You're welcome.
I asked some of you guys what your most painful experience was. Here's what you said.
Ask a friend.
I was on the beach and I jumped off a lifeguard stand and I broke my arm.
Ow!
I had never felt so much pain in my whole entire life.
I was skateboarding and I went flying and I hit the side of my head.
Ow, what a headache. I went skating with my family and I tripped on my dad and his skate went through my hand. Oh.
I fell down the escalator.
Ow!
The really sharp things went in my skin and the ambulance came. It really, 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 really hurt.
I feel pain just hearing about it. And that leads us back to the question that inspired my show.
Why is there pain?
The big answer is...
You know, I'm going to answer your question with a song.
When suddenly you're feeling pain, it's 'cause nerves send signals to your brain. Saying something sharp, cold or prickly. If you stick around, you'll end up sickly. Stings or scrapes, burns or bites. Your nerves tell your brain so you can't take flight. You might wish you didn't feel those things, brain, but you need to get a warning, and that's why there's pain. Yes, you need to get a warning, and that's why there's pain. Yes, you need to get a warning, and that's why there's pain.
Pain is our body's way of warning us that something is dangerous or bad for us. Like if we touch something too sharp, or too hot, or even too cold. It also warns us if we're sick, like if we get a sore throat. So we know to get help from a doctor and slow down to let our bodies heal. Speaking of that, I'm ready to take off this bandage. I just hope it doesn't hurt like the last 2 times I changed it. Hey, it didn't hurt. My cut's healed. Now I don't feel pain in those pain receptors.
Glad to hear it, Zoe.
Thanks. And thanks for watching my show. I can't believe that didn't hurt a bit. Ow, my knee! Welcome to Finding Stuff Out. I'm on a trampoline with a popsicle and earmuffs because of some questions I got. Starting with this one. Sorry, it's just a bit tricky to get my remote without dropping my popsicle. Is there anything left to discover or invent? I don't know, but by the end of the show, I'll find out. Meanwhile, I wish there was an invention that could keep me from dropping my popsicle while I click my remote, because I have another question. Not again.
You know, I'd like to invent something one day. Do kids invent things?
Yes, kids do invent things. And that's why I'm jumping on a trampoline with earmuffs and popsicles. Because all 3 of those things were invented by kids. I found out that 15-year-old Chester Greenwood invented earmuffs in 1870 because his ears got cold when he went skating. Frank Epperson was only 11 when he invented popsicles. George Nissen was a teenager when he invented the trampoline, which he later taught a kangaroo to jump on with him. Jumping with a kangaroo wasn't an invention or a discovery, but it was pretty cool. And kids invented other amazing things too. Like glow-in-the-dark paper, braille that allows blind people to read, an invention that would later become a TV, or a flashlight that turns body heat into light. No batteries required. Okay. Maybe I can invent a hands-free way to hold my popsicle on the trampoline. Maybe not. But kids do invent stuff all the time, and we're going to meet some of them right now and see what their inventions are. This is a huge science fair. 500 kids who love science are here to show off their ideas, experiments, and inventions. And I'm gonna meet some of them right now. Hi, Dylan. So what's your invention?
My project's about generating power from the sun without using solar panels. The way I'm doing this is using mirrors, so the sun is hitting these mirrors, reflecting back, and creating a superheated spot.
That's hot.
My dish needs to be facing the sun at all times, so I developed my own active tracking software.
Cool, but this needs to be bigger, right?
Yes, my plan is to make a very large version. I have a 3-meter dish and a 14-foot arch on top of my roof, and hopefully heat my hot water tank, my house, and power my lights.
Wow, free energy.
Exactly, free energy. This is my passion, and it feels amazing.
It is amazing. Good luck. Our next inventor made something that doesn't use the sun, but it definitely is out of this world. Hi.
Hi, Zoe. My name is Eunyoung Kim, and I invented a glove that's for astronauts to use on Mars.
Whoa.
Since Mars is so dusty, my glove helps astronauts pick up their tools because basically they're blind on Mars. So there's sensors built into this glove, and when the sensors get close to an object, it sends signals to this small computer that makes the glove vibrate.
Do you think NASA will want to use your invention?
Yes, I think it's a good opportunity for NASA to use this glove when they go to Mars.
Woohoo! Let's hope they do. Now here's an invention that you definitely don't need gloves to use. Hi.
My name is Deho Daniel Sky. I'm from a First Nations community called Gahnawage, and my project is the door pedal. The door pedal allows you to open up your door using your foot instead of your hands.
Cool, but who uses it?
I went to my local hospital and I allowed a nurse to try it out because there's lots of germs in the hospital. She said it was very sanitary because she doesn't have to touch the door handle anymore. And also at my grandmother's convenience store. So now when she's bringing big, heavy things into her store, she can now just open it with her foot. This should open doors for me.
Talk about using your head and your feet. And here's Tamid. He invented a wheel that can adjust to any road condition.
You can see that the wheel is a complete circle right now. You can see it changes into something very, very spiky. I've spent many weeks, months on the computer screen trying to get my parts to fit together, and when it finally did, when the wheel was finally able to turn and also change shape, it felt great. Woo! This really works well in sand, in snow, in mud, but then when you come back to a highway, you're able to press the button again and get it back to a circle.
Well, that's like reinventing the wheel. Thanks. Now here are two people who also took a really old invention and made it into something new and amazing. Hi.
Jenna and Elijah are Inuit and live in the far north in Saluit, Nunavut.
That's Hullik Inuit oil lamp.
They worked out a way to use the heat of a traditional oil lamp and make electricity to charge a cell phone.
Heat from Hullik, it make electricity, so you can charge when you're camping.
So you never run out of power. Cool. That's a lot of inventions. But what about discoveries?
Here's a question from Michael.
What is the difference between a discovery and an invention?
Yeah.
What's the difference? That's what I asked some of my friends.
Ask a friend.
An invention is something that you make, and a discovery is when you find something, but it's already made by nature.
A discovery is when you find something new, and an invention is when you make something new.
Well, I checked, and I found out you guys are right. Now,
speaking of discoveries, here's a question from Daniel.
What does eureka mean?
Well, Daniel, when I was trying to find out what eureka means, I found this great story. So
I made this animation.
Archimedes was an ancient Greek mathematician, philosopher, engineer, astronomer, and inventor. Fortunately, despite being very busy, rumor has it he still took a bath regularly. The story is he discovered the principle of displacement when he noticed how the water level rose when he lowered his body into it. When he realized his discovery, he shouted out, "Eureka!" which is the ancient Greek word for "I have found it." Archimedes also discovered that stuff that's less dense than water, like gases for instance, float to the surface instead of sinking to the bottom. We don't know how he discovered that, but you never know.
Eureka! Speaking of Eureka, I had an idea to put bouncy springs on my popsicle, so while I'm on the trampoline, it can bounce along with me.
Oh no.
If I can't invent a way, maybe I'll discover one eventually. I have discovered that kids have discovered a lot of cool things.
When she was 10, Catherine Gray discovered a supernova. That's an exploded star. And Catherine is a bit of a star herself because she's the youngest person to ever discover a supernova. 15-year-old Tom Wag discovered his own planet. And 15-year-old Willem Gattery may have discovered a lost Mayan city by using star maps. And lots of kids have discovered ancient fossils.
Hey, cool! A dinosaur fossil. Here's a question from Mateus.
Who found the first fossils of a dinosaur?
Flat Earth Corner!
I wish I could find something really valuable down here, like gold. Hey, that's odd. There's something there.
Forsooth, I found the bones of a dragon.
Hey, I wonder if these bones would taste good in soup. I could be the first kid to invent dragon soup. People who found the first dinosaur fossils thought they were the bones of dragons.
I guess dinosaurs do sort of look like dragons, but it took a while for people to realize what they'd found. And it took a while for the grand prize winner of the science fair to discover a treatment that might help some people feel better.
Hi Zoe, my name is Melissa, and I was able to make a discovery in many patients that had a type of cancer, lymphoma, so it's a cancer of the blood cells. They're usually treated with something called chemotherapy. Then the cancer patient usually starts to feel really bad because that treatment kills your good and bad cells all at the same time. I wanted to develop a new method to help cancer patients so that they wouldn't become so weak.
Wow. What inspired you to do that?
I have an uncle who has cancer. I also have many friends who are related to other people who also have cancer. So it affects many people, and I wanted to do something that would help a lot of people. I still have a lot more research to do, and hopefully one day be able to really make this treatment available for everybody.
Good luck. Thanks, Melissa.
Now I'm going to meet some inventors who also had a very personal reason for making their inventions. This is Samantha Guay and Tegan Kay. They also wanted to invent something that would help people. Wow, this isn't like any other boot I've ever seen before.
We were inspired to invent it by one of our friends who is almost always getting hurt. She has a lot of accidents.
She fell off a trampoline once.
She fell off her bike.
And a fence.
So I'm guessing this boot doesn't prevent injuries. What does it do?
Our friend was always getting cast, and when she was going out in the rain, it would always get wet, so we wanted to make a boot so she didn't have to get her cast wet.
And the whole cast can fit inside, and it just does up.
To try it out, I put on some extra heavy socks so it'd be like I have a cast.
Now you can put the boot on and see how it works.
Cool, no laces.
How does it feel?
It's comfy. I could see how this could hold a cast. Ta-da!
In the beginning, our invention was going to be on a shoe, but the shape wasn't right. So we picked a boot.
And when we were making the boot, some of the glue wasn't strong enough, so we had to get new glue. And
first, when we were doing it, we used magnets like this on one side and washers on the other side, but it wasn't strong enough. So
we decided to use
magnets on both sides.
Okay, now I'm going to put your boot to the test. So my foot won't get soaked?
Not a chance.
Definitely not.
Okay, I'm gonna go a little bit more daring. Hey, my foot isn't wet. That's awesome.
It's actually meant for puddles, but it works in the shallow end.
What's next for you inventors?
We would like to add some reflectors to the boot to make it more safe at night.
And add some cool designs to make it more fashionable. And we also have come up with a logo.
Puddle jumpers. Awesome. So Samantha and Tegan were inspired by trying to keep things dry. Now here's an invention created by someone who wanted to make sure people could get wet when they need to.
Rachel Brower won medals at 2 science fairs, including a gold medal for her very watery invention.
Hi, Rachel.
Hi, Zoe.
So what did you invent?
So this is a water pasteurization system for third world countries. It removes the bacteria and impurities from water, making it safe to drink.
What inspired you to make this?
So a couple years ago, when I was 11, my family went hiking in New Hampshire. We saw the lakes and the rivers, but then we saw the contaminated do not drink signs. And at the same time, I was reading the I'm Malala book. And in this book, many women and girls are dying from the cholera outbreak. So I put the two things together and I decided I wanted to make a difference.
Cool, so how does it work?
So first the water is pumped from a water hole or lake, and then it runs through this basic cotton and charcoal filter system. Once it runs through this system, the 2-liter bottles are filled up, and then you would remove them from the system.
What did you find difficult?
So though the system removes the impurities, I found that bacteria is also found in water. That's when I designed this novel color-changing wax indicator. So once your 2-liter bottles are removed from the system, you'd place this inside and then place your bottles on a piece of corrugated tin roof. The sun will heat the water to 40 degrees Celsius, and this blue wax will change from dark blue to light pink, indicating that the water's heating up. Then once that water reaches 60 degrees Celsius, this will melt and run into the second vial, indicating that the water is safe to drink.
Wow, that's awesome. So what's next?
And this summer, my system will be tested in Kenya and Pakistan.
Do you have a message for kids who'd like to invent stuff?
Find something you're passionate about, and just because you're a kid doesn't mean that you can't make a difference.
Thanks for being on my show and showing us your invention. Now here's a question from Yasmina.
How many discoveries and inventions are there in this world?
How many inventions and discoveries are there? Let's see. Electricity, fire, air conditioning, toilet paper, the printing press, vaccines, getting warm, refrigeration to keep heads from getting warm, eyeglasses, internet, jet engines, airplanes, helicopters, rockets, compasses, calendars, cars, radio, cranium getting hot, brain starting to overload, pasteurization, telephones, whoa, motors, cars, radio, cranium getting hot, DVDs, drones, routines, synapses firing like a laser, oh no! Ah!
You're gonna make my head explode!
The truth is, nobody really knows how many inventions and discoveries there are, because there have been so many throughout history. And this gives me an idea for a song. Inventions and discoveries, doing something new. They help us do things that we wanna do. Like dreaming up a robot to help us clean our room. Create a kind of rocket to take us to the moon. Energy from the sun, non-polluting cars. Gloves that help you find your tools on Mars. Inventing and discovery, it's doing something new. Inventing and discovering will open doors for you. Inventing and discovering will open doors for you. Inventing and discovering will open doors for you.
My Great Challenge!
Today's challengers are Anjali and Logan.
Yay! Versus Stefano and Sasha.
Yeah!
I'm gonna show you some weird inventions, and both teams have to guess what they are.
If neither team gets the answer, you get a clue.
The team that gets the most correct answers wins. You ready?
Yeah.
Okay, you girls are gonna go first. Okay.
I think it's like for the baby to go inside. And
babies are bigger than this.
So, like the new.
We're going for hammock,
I guess.
Okay.
A hammock?
Yeah.
Sorry, girls, that's wrong. Boys, your turn.
Don't see it. Oh, nice cat.
A bag of litter for cats.
Sorry, guys, that's not it. Okay, you guys get the clue now.
Cat bed.
Yeah.
You guys were right. It's a bed for cats.
Yes.
What is it?
Cheese shredder or
something shredder.
Yeah, it's like a shredder. Yeah, it comes out from here.
Yeah. Is it like a shredder?
Sorry, guys, you're wrong.
So I think it's something that you could put like a fruit or something inside.
A fruit cutter, let's say.
A cutter? Sorry, guys, that's wrong as well. So you guys now get the clue.
A juicer.
Yeah, you guys are right.
Yeah.
You put the lemon in, and you squish it, it comes out. You hear that?
Yeah, I hear it.
Let's see how much juice it made.
You spilled some.
What is it?
It has to be like a decoration for something.
I don't think so.
It's something that we
Used to clean a toilet or something? A drain?
Sorry, girls, that's wrong. Okay, you guys go.
But could it be a decoration? Because this could be the hair. This is another McFly. No, why would it be a doll? But can't you see? Does this look like a doll's hair? Eyes.
Okay, guys, I need an answer.
A decoration.
Decoration? Sorry, guys, that's also wrong. Okay, now you guys get the clue.
Oh, it's a potato smasher?
You guys are right. When it's baked, you mash it.
Oh, I know what it is. It's like one of these old-fashioned bells. Hold on.
I don't think it's a bell.
Yes,
there's no
'cause
like ball inside.
you put the ball inside.
I need a final answer.
What did I say?
A bell?
Sorry, guys. That's wrong.
It's our turn. Is it to take out a core of an apple?
Nope. You guys get the clue.
Maybe a lighter?
No, impossible because there's no fire thingamajig.
Yeah, but you could put something in.
A lighter for candles?
Sorry, girls, it's not it.
Oh, maybe not. Is it to take out the light?
Yeah, you guys are right.
Yes! You use this to put out a candle without burning your fingers.
All right.
Okay, both teams have 2 points.
So this is the tiebreaker. What is it?
A measuring magnet?
A measuring magnet? Sorry, girls, that isn't it.
There's circles on it. Could it be a tracer? Is it a tracer?
Sorry, guys, that's not a tracer. So you guys now get the clue.
Oh my, it's the whole tool.
Is it like to measure the pasta?
You guys are right, it wins. Yes. What you do is you put it in, and that's how you measure it for 3 people.
That's cool, I need that at home.
Well, thanks for being on my show and helping me find stuff out. Now, time to answer the question that inspired my show today.
Is there anything left to discover or invent?
The big answer is...
Well, Anthony, to answer your question, I've decided to ask someone who's gone all the way to space to discover things. Astronaut Chris Hadfield. Chris, thanks for being on my show. So, do you have an answer to Anthony's question? Is there anything left to invent or discover?
Zoe, we have no idea what we're doing. We are just getting started. We don't know what 94% of the universe is even made of. We are just infants. There are so many problems that we need to solve, and we're counting on scientists and engineers and bright young people like you and like people right across the country and around the world to solve those problems. So there's a whole world of things to discover and learn from and improve the quality of life with.
Thanks, Chris. Well, that's my show for today. By the way, notice anything different? I finally invented a popsicle holder that lets me use my remote and take my earmuffs off. See you next time for more finding stuff out. Check out these new chutes.
Great job, Freddie.
Oh, Jerry, you're looking a little thirsty. But don't worry, Zoe to the rescue. Too much water. That reminds me of a question I got from Nora.
How come sometimes there's too much water, but sometimes there's not enough water?
You're right. Some places get flooded and other places turn bone dry.
I know why there wasn't enough water in here. Either Jerry drinks a lot of water or I forgot to water him. Yeah, I forgot to water him. And then I wasn't paying attention and I gave Jerry way too much. So to answer your question, I've come here to Science World to meet Brian, who knows a lot about water. Hi, Brian.
Hi, Zoe.
I've been wondering about water, like how there's too much and sometimes there's not enough.
Well, Zoe, the planet is over 70% water. In fact, there's more water on Earth than there is land. So we're gonna look now about how water can move from one place to the other.
Cool.
One of the ways it does this is through evaporation. Big lakes and oceans, the water will heat up and travel up into the sky.
Oh, forming clouds.
Yeah. Safety first.
Thank you.
We're gonna try the same thing using a little bit of rubbing alcohol. This evaporates very easily. Ready? 1.
Pumping air increases the pressure and heats up the gas. We're gonna release all that pressure when we pull out the nozzle. That makes the gas cool down fast and transforms it into tiny droplets of liquid, which form a cloud.
Got it!
We let the pressure go, temperature goes down, and we have a cloud in a bottle.
Cool. Look at that.
That is awesome.
Same thing happens with real clouds in the air. When water warms up, it evaporates into a gas. When that vapor rises and reaches the sky, it cools down and turns into clouds, which are tiny droplets of water that always find their way back down to Earth. Speaking of that, Maddie has this question.
How does a flood happen?
Well, flood happens when you have too much water. That could be too much water that's built up behind a dam or a dike that's broken through, or it could be too much water coming down from the sky in a big storm. So Zoe, I've brought you a house and a beautiful lake here. Where would you like to place your house?
Let's place by the lake, because I like the lake.
It's true. A lot of people like to be close to the water. Of course, water also likes to flow down. I'm going to turn the water on.
All right.
All right, the water's starting to flow. We've got a gentle rainstorm up in the mountains starting to come down. Maybe a little bit of snow melting up there.
Oh no! Oh no! My house! My new carpet! My new book collection!
That is one soggy house there, Zoe.
I guess we'll have to find a better place for my home.
Sounds like a plan. One thing people can do to help protect houses from water is build dikes and water gates to redirect the water away from where you want it to go.
Let's try and see if my house will go right here.
So this time it's not moving at all. Of course, in big heavy rain, sometimes the dikes will overflow or even break.
Oh no! My house!
I hope you have insurance.
Well, even with the dikes here, I don't feel like my house is completely safe. Oh, this is a great place for my house.
Looks good, Zoe. Nice high ground, safe from a flood.
So the higher you are, the safer you are from a flood.
There's less water to flow through, that's for sure.
I have a question about floods. How high could a flood get?
Floods have been recorded as high as 6 meters.
Am I there yet?
Higher.
Am I there yet?
That's it, 6 meters!
Oh no! Whoa, I made it.
Nice job.
I have a question. How do you get rid of a flood?
That's a great question. As the climate's changing, a lot of people are thinking more about how they can prepare themselves for a flood. In fact, here at Science World, we're looking at the water levels around us and realizing they could go up as much as 1 to 2 meters.
Well, then what do you do in a flood?
The main thing is to stop the water from coming in and dry out the areas that have been affected. This could be using big blowers, heaters. One of the main things is make sure you get all of the moisture out of carpets, furniture, walls, because you don't want any mold starting to grow inside. Everything has to be completely dry.
Well, thanks for the tips. I think it's time we tested them out.
Yeah.
My Great Challenge!
Today's challengers are Ophelia and Nick on Team Turbulence.
Team Turbulence!
And Cecilia and Louie on Team Wildwater.
Team Wildwater.
When I say go, I'm going to release the marble flood water, and your job is to swoop in and save the day by directing the flood away from your houses below. The team with the fewest marbles around their houses by the end of the challenge wins. Are you guys ready?
Yeah!
Okay. And go!
Oh! No, 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 no! No, 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 I swear! Come on! I don't go in here!
Challengers have 2 ways to stop the flood. Using their sandbags, they can divert the rush of the water marbles onto the other team's side or into the drain holes on the edges of the river.
No, no, no! Come on! I don't go in here! Come on! Jesse, go in! Oh!
Trying to push the marbles upstream is useless. They're only going to go back down. Water is really hard to stop.
Come on! No, 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 no!
That's it. No more water.
Judging by the number of marbles around the houses, it's clear that Team Turbulence won!
Yay! Team Turbulence!
Good job, guys. You fought the flood like superheroes.
Flows across the plains. It fills up all the drains. When there's too much water, it can really be a pain. When cold, it turns to ice, and we slide around like dice. There's snow that's fun to play in, but ice storms are less than nice. Oh yeah! Next question.
Why are there ice storms? Well, Leah, I checked, and this is what I found out.
An ice storm is a storm of freezing rain that covers everything in a crunchy, slippery coating of ice. It happens when frozen rain falls through warm air, which melts it, before hitting the cold ground, which freezes it. This forms a layer of ice on trees, cars, a sidewalk, everything.
That's why it's always important to check your weather forecast so you can be prepared for anything. But what if you can't look up the forecast? That reminds me.
How do animals survive in a wild weather?
Oh no, a dog can't look up the weather. A cat can't check the forecast. A moose doesn't have a weather app. An elephant can't look up the temperature. Who warns the porcupines and the monkeys? You're gonna make my head explode!
Whew. Some people think animals have a sixth sense because of all the crazy, cool ways they predict and survive wild weather. But they're just way more observant than us.
Animals tune into the world while we humans have trouble paying attention. Bees sense changes in the air pressure that often lead to rain, so they know exactly when to head inside. Sharks notice big temperature changes in the ocean, meaning a storm's coming, and swim to safety. Most land animals go somewhere high and safe in a water disaster, like this clever dog who survived a flood by swimming up to the roof. Before a tsunami, elephants sense movements in the earth and run to higher ground, trumpeting and warning each other.
I wish I had a built-in trumpet to warn people of tsunamis. Veronica has a question about tsunamis.
How do tsunamis start?
Flat Earth Corner!
Konnichiwa, people. Did you know the word tsunami is Japanese? It's from su, meaning harbor, and nami, meaning wave. Here in 7th century of Japan, we believe Namazu, a giant catfish, lashed its tail, making a giant wave. Oh, come on. We know now, rather than a giant fish, tsunamis are caused by natural events, like landslides, volcanoes, glaciers breaking, and earthquakes. Whoa! 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 I found out that when the earth moves, water moves to fill the gaps.
In a powerful earthquake, the earth under the ocean can be lifted or dropped, which causes gaps. The water above it rises and makes giant waves across the ocean. As the water moves closer to shore, waves get bigger. A tsunami can move as fast as 1,000 kilometers an hour. That's faster than a jet plane.
The experiment!
My friends made a tsunami simulation. Hi, guys.
Hey, Zoe.
Hey, Zoe. So how do you make your tsunami?
First, we use newspaper, dirt, and sand to build our beach.
Then we add some houses and trees to make it more realistic.
Time for the sand. Do you like beaches? Of course.
The highest tsunami wave ever recorded was in Alaska.
Now for the water. I can't wait.
It was 524 meters, about as high as the CN Tower.
Now it's time for the big wave. 3, 2, 1.
Millions of trees were uprooted and swept away. The powerful wave washes up on shore, and as it flows back out, it pulls just about everything along with it. Yikes. Thanks, guys.
Bye, Zoe.
Bye, Zoe. What a crazy place the ocean is, and I'm not the only one who thinks so.
Are there volcanoes underwater?
Well, Emily, I found out that deep beneath the waves, there are about 1 million volcanoes. That's more volcanoes underwater than above. Here's how to make your own.
First, we start with cold water, representing the ocean, then a bowl of hot water, representing the lava-filled volcano. So, We have this little cup and we're gonna fill it with warm water. Next, we put some red food coloring to make it more lava-y. Stir it up. Then, we put the tin foil on, and you want to make it as tight as you can. Next, we poke a hole representing the opening of the volcano.
Whoa! Unlike on land, when a volcano erupts underwater, lava doesn't shoot out because there's so much ocean weighing it down. So you can be in a boat over an erupting volcano and never even know it was there.
Don't worry, little volcano. We know you're there. There are a lot of things happening in, under, and even over the ocean. That reminds me of a question I got from Sophia.
How do hurricanes form?
Hurricanes are pretty picky. To form, the conditions have to be just right. First, they like warm ocean water. Next, we need a lot of wind. Clouds pull water from the ocean up, which makes a tube of super speedy air. This makes a hurricane. Hurricanes are water-moving machines. They suck up water from one part of the planet, and spit it somewhere else, sometimes making floods.
Today, weather scientists make an alphabetical list for the year's coming hurricanes. Xena, York, Zelda, but no Zoe. Phew.
Next question.
How do you respond to hurricanes? To find out more about hurricanes called Sammy or Rosie or even Elaine, I call my special guest, and Dr. Kirsten's her name.
Hi, Zoe.
Hi, Dr. Kirsten. I asked you to come over to be on my show, not move in.
Well, I came prepared for a hurricane.
There's gonna be a hurricane?
No, the forecast is clear, but it's good to be prepared.
So, Amelia wants to know how to respond to hurricanes. That's kind of your job, right?
That is my job. In fact, my job is not only to respond to hurricanes, but to respond to natural disasters or humanitarian emergencies all over the world.
Wow.
I have some pictures of the places I've been. There's one from Haiti, the Philippines. Both countries were affected by earthquakes and hurricanes.
That's crazy.
Sudan, which is affected by drought.
So, it must be hard working in natural disasters.
You know what? It is tough because you don't have the luxuries that you have in your own home. So you have to bring everything for yourself. So it's kind of like camping in a way. We bring our own sleeping mats and, of course, our own sleeping blankets or sleeping bags. In some of these countries that are affected by hurricanes and a lot of water, there are mosquito breeding grounds, which can cause disease. So it's important to bring our own mosquito nets. That keeps us safe from getting mosquito-borne illness at night. Something else that we bring is our own food, because in a lot of these places, people don't have enough. So this is called a ready-to-eat meal. It's one prepackaged, dehydrated meal. All you need to do is reheat or add water, and you're ready to go.
You even bring toilet paper?
Yes, we do. Often in these places, the toilets have been destroyed or they don't work. And so we bring our own toilet paper, but we also bring this system called a pee-poo bag. So these bags are biodegradable and they can be used for human excrement, feces, or urine. And you put your paper inside, wrap it up, and you put it into a pile, and that it can be used for fertilizer for future agricultural initiatives.
That's weird.
Practical, doesn't leave any waste behind. We also need to bring our own ways to make water clean. In these places where there's a lot of water, like in a hurricane, all the water gets mixed together, so often it's not safe to drink.
Yeah.
And so what we often do is bring these kinds of devices where we can actually put a filter into dirty water.
Wow.
And it filters out all of the bad stuff, and you can pump your own water that's safe to drink, just like that.
Wow. This is a lot of stuff you bring to a disaster. I'm gonna ask my friends what they would bring.
Ask a friend. Hey guys, what else would you bring if you already had the essentials?
I would gather all my construction blocks, bring them with me, and then grab my tablet,
my piggy bank, and my stuffed animals. Because you can't bring your bed.
a hockey stick, and a hockey puck. I would bring my favorite doll, because I can't sleep without it. My teddy bear. It would be a hard choice to decide between my stuffed monkey and my parents. Because I love my stuffed monkey, and I love my parents. Yeah, and I would bring a swimming suit to swim.
It seems like there's been a lot more water disasters lately.
You're right, and that's largely due to climate change. And, you know, sometimes not having water can be just as much of a disaster as having too much water. Here's a picture of Lake Chad, which is in North Africa, and it's only 10% of its original size. So you can see how this area that used to be all filled with water is now shrunken down to a fraction of what it originally was.
Dr. Kirsten told me that with climate change, there's been less rain and more drought. Also, there are a lot more people living around Lake Chad, so more people use up the water resources. Same thing is happening in the Aral Sea.
Look at how it shrunk in only 25 years. A big part of it is now a desert.
People need to be really careful about using water.
You know, in Canada, it's like we use 100 of these buckets of water per person for eating and cooking and washing a day. But in some of the places I've visited, people only get 3 of these buckets a day. So you can imagine how much difference that is and how much more water we use.
Well, thanks for helping me find stuff out.
Oh, you're welcome, Zoe.
Not bad, Jerry. Oh, you really bounced back from the flood. Still looking good, Freddie. I think I'm ready to answer the question that inspired today's show.
How come sometimes there's too much water, but sometimes there's not enough water?
The big answer is... water moves. That's right. Water moves around the Earth all the time, but natural disasters make it move even more.
Tsunamis push seawater onto land. Hurricanes suck water from the ocean and spit it somewhere else. Snow melts, and all these things put water where we don't want it. Then there are the places we'd like there to be water, but there isn't. Sometimes this is normal. But other times, drought and other water disasters are made by us.
That's right. I mean you and me. But if we're prepared for a natural disaster, it won't be so disastrous. I hear a storm coming.
It's pouring! Quick, gotta get an emergency bag ready just in case. Hey, where are the pee-poo bags?